Hello viewers, Ronald taking you through the story of A-level pure mathematics, and this video we are going to go through the topic of trigonometry. So this topic is in pure math and is suitable for students in both senior 5 and senior 6, offering principal mathematics as part of their combination. We shall start with a review of O-level trigonometry. So trigonometry is a branch of mathematics that studies the relationship between the three sides and the three angles of a right-angled triangle in terms of ratios, and representing them as trigonometrical ratios of sine, cosine, and tangent. So if you consider this triangle of hypotenuse with a hypotenuse of unit 1, but this adjacent is not known and the opposite is also not known. So how do you identify the opposite and the adjacent? First, look at where the angle is. If the angle is here, where it is facing is what becomes the opposite, and where it is lying and has a right angle sign here is what becomes the adjacent. Then the other side is what becomes the hypotenuse, or the longest side. Now from O-level you covered what we called SOHCAHTOA. So SOHCAHTOA is a short word to help you memorize the expression for sine of an angle, cosine of an angle, and tangent of an angle, whereby if you look at this, so it means that sine is equal to opposite over hypotenuse, just as you can see it here. So this is sine theta is equal to opposite over hypotenuse. Now in this case, since the angle is here, it implies the opposite is here, which is x, and the hypotenuse is here, which is unit 1. Therefore, when I cross multiply, bring this one this side, I realize that sine x is equal to, sine theta is equal to x, as you can see it here. That was so. What about k? K means that cosine of an angle is equal to adjacent over hypotenuse. So when the angle is here, the adjacent is here and the hypotenuse is there. So that's why you see here y over 1 being equal to cos theta. Now when I cross multiply, I'll realize that y is equal to cos theta. So next we shall go to the TOA. So TOA means that tan of an angle is equal to opposite over adjacent. So if you look at this theta, the opposite is x and adjacent is y. Therefore, tan theta will be equal to x over y. Now when you realize, you see that this x is sine theta and this y is cos theta, and that gives us a formula for tan, being that tan theta is equal to sine theta over cos theta. So tan of an angle is equal to sine of an angle divided by cos of that very angle. So always remember that. So that was a review from O-level. Now we shall add on 3 more ratios which you are not familiar with from O-level. That is secant of an angle. So secant of an angle is denoted as sec theta and is the reciprocal of cos. So reciprocal of cosine of an angle is called secant of an angle. Then the reciprocal of sine of an angle is what we call cosecant. So cosecant is written as sec theta. Then the reciprocal of tan is known as cotangent. So cotangent is denoted as cot theta. Quadrants, we shall say that x and y axes divide the plane into 4 quadrants as shown below. So this is our quadrant. You draw a circle and you divide it into 4 parts. So x and y axis. Now there we shall label them. The first quadrant is this and has the word all. Then the second quadrant is this and has the word sine, which is what it means, why we put their sign. Then the third quadrant is this and has the word tan, and the fourth quadrant has the word cos. So what do those words mean? So this word all means that all the three ratios are positive. The ratios, I mean sine, cos and tan, they are positive in the first quadrant. Then in the second quadrant, it is only sine which is positive. That means that in the second quadrant, cos and tan are negative. Then the third quadrant, it is only tan which is positive, meaning that sine and cos are negative. And lastly, in the fourth quadrant is only cos which is positive, meaning that sine and tan are negative. So this quadrant is very, very vital in this topic of trigonometry, and we shall be using it frequently, as you will realize. So with that knowledge, you shall go through these questions. So question 1 says, given that sine A is equal to 12 over 5, where A is an acute angle, find without using tables or calculators the value of Roman 1 cos A, Roman 2 tan A, Roman 3 sec A, Roman 4 cosec A, and Roman 5 cot A. So yeah, and the first thing you should realize is to find out where the angle lies. So since the angle is acute, it implies that it lies in the first quadrant, and the ratio of sine is 12 over 13. So those are the two words we need for you to answer the questions. Now this cos A, remember cos is opposite over hypotenuse, meaning that you are given the opposite, you are given the hypotenuse, but you don't have the adjacent yet. So the first thing to do is to get the adjacent. So let's first do that. So since the since A lies in the first quadrant, we shall come and draw our angle when it is in the first quadrant, just as you can see it here. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. But our interest is in the first quadrant. That's why we draw our right angle triangle in the first quadrant. Then remember that sine A has opposite. So when this is the angle, opposite is where that angle faces, and the hypotenuse is this other side, which doesn't have the right angle sign. So we don't know this adjacent, let it be x, and we shall use Pythagoras theory to come up with the value of x. So the value of x will be 5. Now that we know the adjacent, opposite, and hypotenuse, we can go and answer the questions. The first one was on cos A. So what you should remember is that in the first quadrant, all are positive. Therefore, we shall say that cos is equal to adjacent over hypotenuse, where the adjacent is this 5 and the hypotenuse is 13. That is why you see here 5 over 13. Then Roman 2, they wanted tan, so tan is opposite over adjacent, which will be 12 over 5. Then sec A is the reciprocal of cos A, so cos A is here 5 over 13, meaning that the reciprocal will be 13 over 5. Then cosec A is the reciprocal of sine, so sine was given as 12 over 13, meaning the reciprocal will be 13 over 12. And lastly, cot A is the reciprocal of tan, therefore tan was 12 over 5, meaning that its reciprocal will be 5 over 12. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for that substitution, and A1 for the B1 for getting the adjacent. Then B1 for this, B1 for that, B1 for this, B1 for this, and B1 for that. So that was question 1. Now we shall go to question 2. Question 2 says, if tan theta is equal to negative, so know that there is a negative here, negative 8 over 15, and theta is obtuse. Find, without using tables or calculators, the value of cos theta, sin theta, sec theta, cosec theta, and cot theta. So in this case, we should realize that the angle is obtuse and tan is negative. So we will go and draw our right angle first. So the angle will be in the second quadrant, because obtuse means that the angle is greater than 90 but less between 90 and 180 degrees. Therefore, we shall come and draw our quadrant and put our right angle in the second quadrant. Remember, we said that this is the first quadrant, this is the second quadrant, and this is the third quadrant, and this is the fourth quadrant. But our interest is the second quadrant. That's why the right angle triangle is in the second quadrant. Then angles, should remember that they are measured from the horizontal axis, and if it's going in the anticlockwise direction, to be positive. Then from there, we shall remember that tan is equal to opposite over adjacent. So for this, it implies that the opposite is here and adjacent is here, meaning that the hypotenuse is not given. So we have to use Pythagoras theory to come up with the hypotenuse, which will be 17. Now that we have the opposite, adjacent, and hypotenuse, we can answer the questions. First was cos. Cos is, now here we realize that there is negative. Why is it negative? Because we said that in the second quadrant it is only sine which is positive, meaning that cos and tan will be negative. So that is why you see a negative here on cos, and the adjacent is here and the hypotenuse is here. Therefore it will be 15 over 17, but a negative has to be seen. Then we shall go to sine. Sine is opposite over hypotenuse, but in the second quadrant sine is positive. That is why you don't see any negative there. The opposite was 8 and hypotenuse was 17. The next will be sec theta. Sec theta is the reciprocal of cos theta, which will be negative 17 over 15. And cosec theta is the reciprocal of sin theta, which will be 17 over 8. And lastly, cot theta is the reciprocal of tan theta, which will be negative 15 over 8. So basically that's what they wanted. So M1 will be for this substitution, B1 for getting the hypotenuse, B1 for this, B1 for that, B1 for that, B1 for that, and B1 for that. So that was question 2. Now we shall go to question 3. Question 3 says that if tan theta is equal to 7 over 24 and theta is reflex, find, without using tables or calculators, the value of cos theta, sin theta, sec theta, cosec theta, and tan theta. So in this case, they have told us that the angle is reflex. Now the reflex means it is between 180 and 360. And if you are keen, you realize that the angle between 180 and 360 is has two quadrants. That is the third quadrant and the fourth quadrant. So the question is, how do you know which quadrant? To know which quadrant, you look at this ratio given. You are given that tan is positive in that quadrant. So you ask yourself, in the third quadrant and the fourth quadrant, where is tan positive? So you have already seen that tan is positive in the third quadrant. Therefore, this reflex angle will lie in the third quadrant. So when we realize that, we can come and draw our right angled triangle. So remember, angles are measured from the horizontal going in an anti-clockwise direction for them to be positive. So we are given tan theta being equal to 7/24, so that when the angle is here for the right angle triangle, the opposite is here, that's why you put 7 there, and the adjacent is here, which has the right angle sign. So the hypotenuse is not given. Therefore, the first thing to do is to use Pythagoras theory to come up with the hypotenuse, which is 25. Then you can answer the question. So cos is negative. Why? Because in the third quadrant it is only tan which is positive, meaning that sine and cos are negative. That is why you see a negative here. Then for sine theta it is also negative, and also for sec theta will be the reciprocal of cos theta, which will be negative 25/24, and cosec theta will be the reciprocal of sine theta, which will be negative 25/7, and lastly cot theta will be the reciprocal of tan theta, which will be positive 24/7. So basically that's what they wanted. So M1 will be for substitution, and B1 for hypotenuse, B1 for this, B1 for that, B1 for this, B1 for this, and B1 for that. That was question 3. Now we shall go to question 4. So question 4 says that given that cos theta is equal to 3/5 and theta is between, it ranges from 180 degrees to 360 degrees, find without using tables or calculators the value of sine theta, tan theta, sec theta, cosec theta, and cot theta. So the first thing to do is to realize that this angle ranges from 180 to 360, has 2 quadrants, and that is the third and fourth quadrant. So the question is, which quadrant is of interest? So to know the quadrant, you look at this ratio. When you look at this cos, it is positive, meaning that cos is positive in the fourth quadrant, therefore this angle is in the fourth quadrant. So like I told you, that diagram for quadrants is used frequently in this topic, so you must be conversant with it. So we shall remember that cos is equal to adjacent over hypotenuse. So we shall come and draw our right angle triangle in the fourth quadrant and put the angles here. Opposite is not known, the adjacent is 3 and the hypotenuse is 5. Therefore we shall use Pythagoras theory to come up with the opposite, which is 4. Therefore we shall come and answer the question. So sine, I think we realize that there is a negative because in the fourth quadrant it is only cos, which is positive, meaning that tan and sine are negative. That's why you see negative here, and also on tan you'll see a negative there. Then sec is the reciprocal of cos, which will be positive 5/3, and cosec is the reciprocal of sine, which will be negative 5/4, and cot is the reciprocal of tan, which will be negative 3/4. So basically that's what they wanted. Now M1 will be for this substitution, B1 for getting the opposite, B1 for that, B1 for this, B1 for this, B1 for this, and B1 for that. So we have seen how to get trigonometrical ratios without using tables or calculator. Now we shall draw some of the graphs of trigonometrical functions, and that is graphs of sine and graphs of cos and of tan. So we shall start with the one of sine x against x. We shall start by drawing the axes and labeling them, then demarcating the axes. Then we shall now draw our graph in that. Okay, so what you should realize is that in this graph, the graph never exceeds +1. I think you see this line denotes +1, and the graph never exceeds +1, and also it never exceeds -1. That is what you should always remember, and that was the interest of drawing this graph, to show you that sine x is maximum. The maximum value of sine x is +1, and the minimum value of sine x is -1. So this concept is very vital and will be used towards the end of this video. So this is what I was talking about, that the maximum value of sine of any angle is always equal to +1, while the minimum value is always equal to -1. Then now we shall go to the graph of cos x against x. So those are the axes were labeled. Now we shall draw the graph inside the axes. So in this graph, still, what you should realize that the graph never exceeds +1, and it also never exceeds -1. What does that mean? It means that the maximum value of cos x is +1, and the minimum value is -1. Then also realize that cos 0 is equal to +1, and cos 90 is 0. Unlike sine x, for sine x, sine 0 was 0 and sine 90 was +1. So lastly, we shall draw the graph of tan x. So for tan x, unlike the graphs of cos and sine, which have a maximum value of +1 and minimum value of -1, tan x does not have that. What it has, you realize that at some points, for example, if you get your calculator and you press tan 90, you realize that it will give you math error. If you press tan 270, it gives you math error. Why? Because at these points where I've put the vertical lines, tan is undefined. The value of tan theta is undefined. In other words, it tends to infinity. Therefore, tan does not have maximum and minimum values. It only has points where it tends to infinity. That is why I put these vertical lines. So when I come to draw it, the shape will be in that form. So what you realize is that the value of this graph never touches this line. It never touches that line, meaning that there's no value of tan 90, and there is no value of tan 270, and there's no value of tan -270, and there's no value of tan -90. So you can prove that by getting your calculators and pressing those values. You realize that it gives you math error. Therefore, we shall conclude that the maximum value will just be tending to infinity, so positive infinity, and minimum will be negative infinity, meaning that it is not actual, it is not finite. So those are the graphs. Next we need to know is radians and degrees. So the angle can be measured in either degrees or radians. Sometimes they can give you an angle in degrees, and they tell you to convert it to radians, or they give you an angle in radians and tell you to convert it to degrees. So if you are taught to do that, you must remember that pi rad is equal to 180 degrees. That means that 1 degree is equal to pi over 180 rad. Therefore, if you are given an angle in degrees, you can convert it to radians by multiplying by pi over 180, just like it is here. 15 degrees will be 15 times pi over 180 to come up with pi over 12. Then 30 degrees will be 30 times pi over 80 to come up with pi over 6. Then 45 will be 45 times 180 times pi over 180 to come up with pi over 4. Then 60 degrees is pi over 3, 75 degrees is 5 pi over 12, and 90 degrees is pi over 2. So those are some of the angles, but what I wanted you to realize is to know how to convert from degrees to radians. Now we shall go to positive and negative angles. So some angles are negative and other angles are positive. So how do you know that this angle will be negative and this angle will be positive? For you to know, it depends on the sense at which you measure the angle. So if you measure that angle starting from the x-axis but going in an anti-clockwise direction, then that angle will be positive. But if you measure it from the x-axis going in a clockwise direction, that angle will be negative. For example, if I have this x-axis and that is the y-axis, I measure from this side going this side, that angle will be positive. So let's do that. So that will be a positive angle, but if it starts from here going in this direction, the angle will be negative. So let's do that. So that is a negative angle. So that's how you can know that the angle I've measured is positive or negative. So you have seen positive and negative angles, and also how to convert from degrees to radians. Now we shall go to another heading, which is basic trigonometric equations. So a basic trigonometric equation will usually have two or more solutions, that is, values of theta ranging from 0 degrees to 360 degrees, or values of theta ranging from negative 180 degrees to 180 degrees. Now, to solve a basic trigonometric equation such as sine x equal to k, the following steps are followed. So now from this step onwards, you need to be very, very attentive. So the first step is to find the first quadrant angle. I think you remember I told you quadrants will be used frequently in this topic, as you will see. So the first thing to do is to get the first quadrant angle and call it alpha, and that alpha will be got by getting sine alpha equal to magnitude of this. Remember we said the maximum value of sine is positive 1 and minimum is negative 1. What does that mean? It means that this value of k can be positive or negative as long as it ranges from positive 1 to negative 1. So for you to get the first quadrant angle, you first ignore the negative and use only the magnitude. Then after getting the first quadrant angle, you identify the quadrants in which theta will lie. Now this one is a little confusing, but we shall see, we shall explain it in detail in every example for you to understand it. Then 3 is to determine the corresponding angles for those quadrants using any of the diagrams. So remember we said that the ranges can be from 0 to 360 degrees, or they can be from negative 180 to 180 degrees. So if it is from 0 to 360 degrees, this is the quadrant which is of interest, and if it ranges from negative 180 to 180, the quadrant of interest is this. So what does this quadrant say? That if the angle is in the first quadrant, it implies that it is equal to the first quadrant angle. If it is in the second quadrant, to get that the required angle to be 180 degrees minus alpha, where alpha is this first quadrant angle. If it is in the third quadrant, you get it by getting 180 degrees plus alpha, and if it is in the fourth quadrant, you get it by getting 360 degrees minus alpha. That is if the angle given ranges from 0 to 360 degrees. So as I'm explaining, it may be a bit difficult to understand, but when we do the examples, you realize that it is easier to understand. So for this case, we still use this. So first quadrant, we use that. Second quadrant, we use that. Third quadrant, we use this. And fourth quadrant, we use that. Remember, we said angles measured going in the clockwise sense are negative. So in the fourth quadrant, it means that you're measuring from here going this side. That's why you see a negative here. And third quadrant means that you're measuring from here going this side. That's why you see a negative there. So we shall do this question for you to master what you have talked about. So question 1 says, solve the following trigonometric equations. Sin theta equal to 0.3814 for values of theta ranging from 0 degrees to 360 degrees. And part B, cos theta equal to negative 0.6667 for values of theta ranging from 0 degrees to 360 degrees. Then tan of theta minus 60 degrees equal to 0.5733 for values of theta ranging from negative 180 degrees to positive 180 degrees. So now we shall start with part A. So part A, they gave you that sin theta is equal to this, and they want the value of theta from 0 degrees to 360 degrees. So like we said, the first step is to get the first quadrant angle, and the first quadrant angle is got by saying arc sine of this, just as you see it here, and it gives you 22.42. So arc sine on the calculator is got by first pressing shift, then you press the button of sine. So it will give you this angle, which is 22.42 degrees. Then from there, you have to realize that sin theta is positive, meaning that it lies in the first and second quadrant. Now, because it lies in the first and second quadrant, and the range of angles is from 0 to 360 degrees, means that we're going to use this circle here, and in this diagram, first quadrant is got by that, and second angle is got by that. So our values of theta will be this first quadrant angle and 180 minus the first quadrant angle. But we can also illustrate it for you to easily understand this. So let's do the illustration. So this first quadrant angle is put on the horizontal. Put on the horizontal. Put on the horizontal. Then from there you ask yourself, what angle do I want? So the angle must be measured from the positive x-axis. So the first one will be from here up to here, and the second one will be from here up to there. Then you ask yourself, how can I get these values of theta? So the first value of theta is exactly the same as this angle, that's why I see it here. Then the second value of theta will be got by saying 180 minus the first quadrant angle, which is 22.42, which gives you 157.58. I think you realize that it is similar to this formula which was given in this diagram. This diagram, second quadrant is 180 minus alpha, and in our case alpha has been 22.42 degrees. So 180 minus 22.42 degrees is what gives you this angle. So you can either choose to draw this, or you choose to memorize this diagram. Any of the two is okay. But since we are just beginning, so since this is the first example, we shall be illustrating both approaches. So basically that's what they wanted. And B1 will be for getting this first quadrant angle, another B1 for getting the first angle which is required, and this one for getting the second angle which is required. Then we shall go to part B. Part B, they gave you this. Therefore, the first quadrant angle, remember we said we use magnitude. That is why here there is a negative, but here there is no negative, because we use magnitude to get the first quadrant angle, which will be 48.19 degrees. Therefore, after that, we shall find out which quadrants is cos negative. So cos is negative in the second and third quadrant. After realizing that, you can either remember this diagram, that in the third and second, the values are got by saying 180 minus alpha and 180 plus alpha. If you remember that, you are good to go. Or if not, you can come and draw this diagram. Then on that diagram, you remember that the first angle will be that and the second will be that. Therefore, meaning that the first value of theta will be 180 minus alpha, which is that, and another value of theta will be 180 plus alpha, which is that. So you can either draw this diagram or you recall this diagram. So B1 for you to get the first quadrant angle, and this one B1 for you to get the first angle which is required, and another one for getting the second angle which is required. So now we shall go to the last part, which is this, and the range is now from negative 180 to positive 180. Now the first quadrant angle is got by saying arctan of this, because here there is tan, so it will be 29.83. Now after that, you realize that tan is positive in the first and third quadrant. Therefore, you can either use this, like I said here, we shall use both diagrams so that you can identify which one is easier. So for this one, first quadrant is that, and also third quadrant is that. So the angles will be the first quadrant angle and also negative of 180 minus alpha. So those are the two angles we are interested in. However, you can also draw this diagram to come up with what is needed. So that diagram, we shall say that the first angle for this first quadrant, it implies that theta minus 60 degrees is equal to 29.83. So when I make theta the subject, it will be 89.83. Then the other angle was in the third quadrant, and the third quadrant we said we use negative of 180 minus alpha. That's why here we shall say theta minus 60, because the whole of this is the angle she was given. That's why you put here theta minus 60. And to be equal to negative of 180 minus alpha. Then after that, we shall make theta the subject. So when I make theta the subject, it will be negative 90.17 degrees. So those are the two angles they wanted. This one is for getting this one is for getting that, and this one is for getting that. So that was basic equations. Now we shall go to trigonometric identities and Pythagoras theorem. So from mathematical logbook, so as long as you are in A-level, you are supposed to get a mathematical logbook, because that logbook has mathematical tables which are used in math for A-level, and also a list of formulae which are useful as you are doing your exam. So in that mathematical logbook, when you look at page 60, you'll find a list of trigonometric identities. Actually, a sample of that list is here. So the identities range from number 12 to number 26, which is a number of identities. So all these identities are very useful in this topic of trigonometry, and this video, and by the end of this video, you must know how to use each of these identities. So we are going to start with the identity which require Pythagoras theorem. So those identities are these first three. So we shall be breaking them down for you to understand them well. So we shall start with these first three. Now those first three identities require Pythagoras theorem, and they have been listed here, where the first one says that cos squared A is plus sine squared A is equal to 1, and the second one is 1 plus tan squared A is equal to sec squared A, and the third one is 1 plus cot squared A is equal to sec squared A. And the note is that these identities can only be derived and not proved. Now in trigonometry, identities can either be derived or proved or shown. Now showing and proving is the same, but deriving is different from those two. Now deriving, in an examination they cannot tell you to derive an identity, meaning that there's no need for you to understand how these identities are derived. But since this is the first set of the identities, we are going to derive them for the sake of just knowing how derivations are done. But in the preceding identities which require deriving, the derivation part will be ignored. It's only those which require proving that is our interest. So since this is the first set of identities, let's see how they can be derived. So in deriving, we are going to consider a right-angled triangle, which is that. And this triangle will be of hypotenuse having a length of unit 1. So by Pythagoras theorem, we shall say that x squared plus y squared is equal to 1 squared, which is 1. But we know that sine A is equal to opposite over hypotenuse, where opposite is this and hypotenuse is that. When I make y the subject by cross multiplying, you realize that y is equal to sine A. Also, cos A is equal to adjacent over hypotenuse, where adjacent is this and hypotenuse is that. Meaning that when I make x the subject by cross multiplying, x will be equal to cos A. So now that I know x and y, I can go and substitute them in this formula of Pythagoras theorem. So when I substitute, I'll come up with that cos A in bracket squared plus sine A in bracket squared is equal to 1. Now in trigonometry, we write this in a unique way. So we write that in this way. We say cos squared A. Now cos squared A means that you get the whole of cos A and you square it. Then sine squared A, we get the whole of sine A and we square it. So that's what this means. It means that though the square is here, you must remember that the whole of cos A has been squared. And also, though the square is here, you must remember that the whole of sine A has been squared. So that is the unique way of writing the squares in trigonometry. You must remember that. So basically, that is the first identity. I think we have derived that. Now next is the second identity. The second identity will be got from the first one by dividing throughout by cos squared A. So when I divide throughout by cos squared A in this first one, I'll come up with this. then you realize that this and this cancels, then this and this. You remember at the start of this topic we saw that tan is equal to sine over cos. Therefore, since this is sine over cos, it implies that it gives you tan, this gives you 1 and this gives you tan squared a. And we also saw that the reciprocal of cos is sec. So since this is cos squared, this will be sec squared. So that is the second identity. Now we shall go to the third identity. Now say we shall go to equation 1 and divide through by sine squared theta. So this was not supposed to be equation, this 2 is not there, so this is not equation 2, it is equation 1 because we are using this one. So you edit that. Now when I divide through, you realize that cos over sine is the reciprocal of tan, meaning that gives you cot, and sine over sine cancels to give you 1. Then reciprocal of sine is cosec, and that is the third identity. So like I said, deriving is not examinable. So this part, though we have derived it, what you must remember is these identities, this, and this, which are found in the mathematical logbook. And remember, in an examination you are allowed to go with your mathematical logbook. So there's no need to derive that. Now with those three identities, we are going to go through a number of examples got from UNEB. So here on this platform, priority of the questions are got from the UNEB Question Bank. So question 1 came from UNEB 2017, paper 1, question 2, and it says, solve the equation 3 tan squared theta plus 2 sec squared theta equal to 2 in brackets 5 minus 3 tan theta for values of theta ranging from 0 to 180 degrees. So this is the expression which was given. Then you shall remember the identity that if I want to change, okay, my aim is to put all into one trig ratio. We have here tan, meaning that I can change this one in terms of tan. So I'll go back to my list of identities and remember that sec squared theta is equal to 1 plus tan squared. Therefore, that is why you see here that I came and changed. Where there was sec squared theta, I'm going to put there 1 plus tan squared theta. After that, I'm going to open brackets and collect like terms. When I collect like terms, I realize that this tan squared theta is 5 because this is 3 and this 2 with this gives you 2. So 3 plus 2 gives you 5. That's why you see at 5 tan squared theta. Then this with this is 2, but there is also 10 here. So when 10 comes here, 2 minus 10 gives you negative 8, which is there. Then when this one goes this side, it becomes positive 6, which is there. Now that I've got a quadratic, I can use either bulldozer method to solve. So when I use bulldozer method, I'll come up with that. So remember, bulldozer, it is negative b plus or minus b squared minus 4ac over 2a. So negative b, so b is positive 6, meaning that negative b will be negative 6. Then here this is b squared and this is 4 times a, where a is 5 and c is negative 8 over 2a, where a is 5. So when I simplify, I come up with two values of tan theta. One value will be 0.8 and another value will be negative 2. And arctan of that will give me, here to be 38.66 and here to be 116.57. Now here I'm getting 1 value because of this range. The range is from 0 to 180 degrees. Now here it is already positive, meaning that it will just be arctan 0.8 to give me 38.66. But for this one, it is a negative, so you have to come here and remember that from this quadrant, tan is negative in this second quadrant. So in this second quadrant, for you to get the required angle to be 180 minus alpha, where alpha is the first quadrant angle. So if I get the calculator and I press arctan of 2, positive 2, because first quadrant angle is got by using magnitude, so arctan of positive 2 will give me 63.43. So what does that mean? It means that the angle which is required will be got by saying 180 minus 63.43. So that is where this angle of 116.57 is coming from. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for expanding sec, another B1 for this quadratic equation, this M1 for solving. You can either factorize or use bulldozer. Then B1 for the values of theta, and A1 for both values for both angles which are required in the given range. So that was question 1. Now we shall go to question 2. Question 2 came from UNEB 2013, paper 1, question 3, and it says solve 5 cos squared 3 theta equal to 3 in brackets 1 plus 3 theta for values of theta ranging from 0 to 90 degrees. So I'll first code the form statement expression which is given. Then from there I realize that I have here sine, but here it is cos. So I'll go back to my identities and see how I can change from cos to sine. So if I go to these identities, I'll realize that this first identity can help me change from cos to sine by taking this one this side to become 1 minus sine squared. So I'll come here and say that this one will be equal to 1 minus sine squared. Remember, the angle does not change. Then from there I'll open brackets and collect like terms to get a quadratic. Now that quadratic I can use now bulldozer to solve. So when I use bulldozer, I'll come up with 3 theta equal to 0.4 and theta equal to sine 3 theta equal to 0.4 or -1. Then I use the calculator to get the values of 3 theta. Now the values of realize that this angle is greater than this 90, but I'm putting it there. Why? It is because these angles are for 3 theta. Now what does 3 theta mean? It means that you go to this theta and multiply by 3. So when I multiply 3 by 3 theta, when I multiply 3 by 90, I'll come up with 270, meaning that the maximum angle must be 270. Now since this 156 is less than 270, it means that it is still in the required range. In this case, it is 270 and you can't add another angle because it will be outside the range. Now this one is easier because it is positive. You just press arc sine. So arc sine of 0.4 gives you 23.58. Then from there you remember that from my quadrants, sine is positive in the first and second quadrant, meaning that in the second quadrant I'm going to get 180 minus theta. So when I come here, the second value, this value will just be got by saying 180 minus 23.58 to come up with 156.42. Now for this one, sine is negative, meaning that you come and ask yourself, where is sine negative? So sine is negative here and in the third and fourth quadrant. So in the third quadrant it will be from here up to here, which is In the third quadrant, it is, sorry, we are using this range. So in the third quadrant, it will be 180 plus alpha, which is the first quadrant angle. Now, how is that first quadrant angle got? We are going to come here and ignore this negative and say arc sine 1. When I press arc sine 1, I'm going to get 90 degrees. Now when I get 90 degrees, I'll come back here in my quadrants and realize that in the third quadrant, the angle is got by saying 180 plus alpha, which is the first quadrant angle. So this value was got by getting 180 plus 90 degrees to give you 270 degrees. Now we cannot add on the angle in the third quadrant because that will be beyond the required range. So now from there, remember they don't want 3 theta, they want theta. So you have to divide throughout by 3. When I divide throughout by 3, this divide by 3 gives me that, this divide by 3 gives that, and this divide by 3 gives that. So basically that's what they wanted, and now let's see how much can be awarded. So this B1 is for expanding this to give you this, and this B1 is for getting the quadratic equation, and this B1 is for solving. You can either factorize or use bulldozer. B1 for both values of sine 3 theta, and A1 for all angles correct. So all these 3 angles must be correct. So that was question 2. Now we shall go to question 3, which came from UNEB 2012, paper 1, question 10a, and it says solve the equation, and this is the equation for x in the range of from 0 to 180 degrees. So we shall first rewrite what we are going to say. Since this is raised to the power 4, we are going to first let y to be equal to cos squared x. When it is that, we realize that in this expression, the whole of this will become y squared, and this will become y. Now we have reduced it to a quadratic. So now that it's a quadratic equation, we can use bulldozer or factorize. So when I use bulldozer, I'll come up with those two values, y is equal to 0.5 or y is equal to 0.75. But remember, we said y is cos squared x. Therefore, we shall come and say that for y equal to 0.5, it implies that cos squared x is equal to 0.5, meaning that cos squared is equal to plus or minus of square root of 0.5. Therefore, the values of x will be 45 and 135 degrees. So hope by now you know how to get these multiple angles using the quadrants. Then for y equal to 0.75, it means that cos squared x is equal to 0.75 and cos x is equal to square root of plus or minus square root of 0.75, meaning that the angles are 30 degrees and 150 degrees. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for the quadratic equation, M1 for solving, B1 for the values of y, M1 for the first value of cos x, this part, and this one is given at this point. This one is given at this point, and this one is given at this point. So that was question 3. Now we shall go to question 4, which came from UNEB 2005, paper 1, question 6, and it says solve the equation, that is the equation for values of theta ranging from 0 to 360 degrees. So we shall first rewrite the equation, then we use the identities. So here we have cos, and this is sine. So what we are going to do, we have to go back to our identities and see how we can express sine squared theta in terms of cos, and that is the first identity. So make sine squared theta the subject, this will go the other side to become 1 minus cos squared. So that is what we are going to write here, that 1 minus cos squared, that very angle, the angle doesn't change. Then we shall open brackets and simplify to get a quadratic equation. Then we can solve the quadratic equation to come up with those two values of cos theta. Therefore, for this one, it implies that this is undefined. I think you remember in the graphs we drew, we saw that the maximum value of cos an angle is positive 1, but this is positive 2, meaning that is beyond positive 1. That is why it is undefined. Then for this one, the values will be 120 degrees and 240 degrees. I believe by now you know how to get multiple angles from the quadrants. Like I said, quadrant will be used more frequently. So now let's see how marks can be awarded. So B1 for expanding, writing from here to here, that is B1. Then another B1 for the quadratic equation, M1 for solving, B1 for values of cos theta, A1 for both angles. So that was question 4. Now we shall go to question 5. Question 5 came from UNEB 2004, paper 1, question 10a, and it says, find the values of theta where theta ranges from 0 to 360 degrees, which satisfy the equation, and they give you the equation. So the first thing to do, we are going to rewrite the given equation, then you look for ways of simplifying it. So the one of the way is to divide throughout by cos squared theta. So if I divide throughout by cos squared theta, you will realize that this gives me tan squared theta. This one cos here goes with this cos, and one cos is divided by this sine, and sine over cos is tan. That is why there is tan theta here, and this 2 is still there, and this minus is still there. For this side, this cancels to remain with only 3, and this minus is still there. So in this case, you have got a quadratic equation which you can solve. You can either use bulldozer or factorize. So when I factorize, I'll come up with that, and those are the two values of tan theta. Therefore, for this value of tan theta, these are the angles, and for this value, these are the angles. So by now, I believe you know how to use the quadrants to get the multiple angles. So for this range, those are the values of theta, and basically that's what they wanted. So M1 is for dividing through by cos squared theta, and B1 is for getting the quadratic equation, M1 for solving, B1 for the values of tan theta, and A1 for all the angles. So that was question 5. Now we shall go to question 6, which came from UNEB 2000, paper 1, question 13a, and it says, solve this equation for values of theta range from 0 to 360. So we are going to first rewrite the given equation. Then we look at this. If you look at this, here we have cosec and here we have cot. So we have to look for an identity which can convert cot squared to cosec squared. When you go to our identities, you realize that this third one, number 14, relates cosec and cot, meaning that's the one we are going to use by taking this one, this side to become cosec squared minus 1. So when we come here, we shall rewrite that. So this cot squared is going to become cosec squared theta minus 1. The angle doesn't change. Then here we shall open brackets to come up with this. Next is to collect like terms to come up with a quadratic, and you solve the quadratic. So you can either use bulldozer or you factorize. So if I choose to factorize, I will say that let y be equal to cosec theta, meaning that this becomes that, this becomes that, and this becomes that. Therefore, I will factorize to come up with this and get the values of y, after which I'll be able to get the values of cosec theta. Then from there, remember that cosec theta is the same one, is the reciprocal of sine. So if this is 6, it here to be 1 over 6, and this is negative 1 to be negative 1. Then from there, for sine theta equal to 1 over 6, these are the angles, and for sine theta equal to negative 1, these are the angles. So basically that's what they wanted. Now let's see how much can be awarded. So this is for expanding, and this one is for the quadratic equation, and this one is for solving, and this one is for the values of cosec theta, and this one is for all angles, correct? So now we shall go to another part which is called compound angle formula. Still those identities are got in the mathematical logbook. So previously we have seen these ones which require Pythagoras theorem. Now the compound angle formulae identities are from here up to here. So these ones are now the ones we are going to look at in this part of compound angle formula, and they have been rewritten here. So this is number 50. So the compound angle formula, I think we realized that here there are two signs and here there are two signs. What does that mean? It means that if I'm using the upper sign here, I also use the upper sign here, meaning that cos A, so if I start with cos, so cos A plus B, here the upper sign here is plus, and here the upper sign is minus. That is why here you see cos A plus B, and here it is minus here. So cos A cos B minus sin A sin B. Then when you use the lower sign, here it is minus, and here it is plus. That's why you see here minus, and here you see plus. Then for sine, here it is plus, and also here is plus. That's why you see a plus and plus. Then downwards, here it is minus, here it is minus. That's why you see a minus and minus. So you must be able to know these identities. If you don't know, then you have to go with a mathematical logbook in your examination, which is very much advisable because it is not easier to memorize these identities since they are many. But if you can, well and good. Then for this term, if this is plus and this is plus and this is minus, so we shall come here and write this is plus, and this is minus. Then for the lower part, this is minus, this is plus, minus, and this is plus. So we shall come and write minus, minus, plus. So like we said, there are some identities which can only be derived and those which can be proved. So in this case, these ones can only be derived, so we don't need to know how they come about. But these ones can be proved, so since they can be proved, you have to know how they come about. And we shall see that in the preceding questions. Now there is some special case of compound angle where one of the angles is 90 degrees. For example, in these identities, if A is 90 degrees, we are going to come up with these identities. The first one will be cos 90 plus B will be equal to cos 90 cos B minus sin 90 sin B, which gives you negative sin B. Because why it is because when you get your calculator and you press cos 90, you'll get 0, meaning that the whole of this becomes 0. And also when you get the calculator and you press sin 90, you'll get 1, meaning that this is negative 1 times sin B, which gives you negative sin B. So always remember that cos of 90 plus B is equal to negative sin B. However, cos of 90 minus B is equal to positive sin B. If you expand this, this is 0 and this is 1, so you get positive sin B. Then sine of 90 plus B gives you positive cos B, because this one cancels, this is 0 and this is 1, so you remain with only cos B. And sine 90 minus B is still cos B, because this one cancels and you remain, and this one is 1, so you remain with only cos B. Then tan of 90 plus B, we're already saying that this one is this and this is this, so we end up with negative cot B. Then of tan 90 minus B, we have seen that this is this and this is this, so you end up with positive cot B. So that is the special case of this compound angle formula and to be used. So with that list of compound angle formulae, we are going to go through these questions. So question 1 came from UNEB 2013 paper 1 question 14a, and it says prove that tan A minus B is equal to tan A minus tan B over 1 plus tan A tan B, and hence show that this is equal to this. So like I told you, in these identities, number 15 and number 16 can only be derived, so we don't need to know how they come about, but number 17 can be proved, so we have to know how it comes about. And this question, we are going to see how this becomes that. So first we shall remember that tan is equal to sine over cos, and the angle remains the same. Then from there, remember that this can be expanded using this, because from these trig identities, sine A minus B is equal to sine A cos B minus cos A sine B. So that is what we shall write here, sine A cos B minus cos A sine B. But cos A minus B, when you come here, cos A minus B, it is cos A cos B plus sine A sine B. So we shall come here and write cos A cos B plus sine A sine B. Then next is to divide throughout by cos A cos B. So when I divide throughout by cos A cos B, this one by cos A cos B gives me this, and this gives me that, this gives me this, and this gives me that. The reason is to express in terms of tan. Now why do we use cos A cos B and not sine A sine B? It is because if the proof wants tan, it means that the denominator will be cos. If the proof wanted cot, it implies that we would put sine as the denominator. That's why here we have to divide by cos throughout, so that we can be able to get our tan. For example, if you look at this and this cancels, but this will be able to give me tan, which is there. But if I had used sine, I would have got cot, which is not required. Then here this cancels and this gives me tan B. Here this cancels and this cancels, that's why we have 1 here, and here this cancels and we remain with tan A. Sorry, doesn't cancel. This and this gives me tan A, and this gives me tan B. Now for the hence part, they want you to show that this is equal to this. Now this word hence means that you start from where you have stopped. Now where we have stopped, you have seen that this is equal to that. Therefore we shall come and compare and say that this required given expression is equivalent to this form, but you've already seen that is equal to tan A minus B. Therefore what you are going to do, we are going to compare. This equivalent sign means you can compare. So when I compare, this will be this and this will be that. So you come and say that by comparison, tan A is equal to 1, meaning that A is 45 degrees. When I press arctan 1, I'll get 45 degrees. Then tan 15 is equal to tan B, meaning that B is equal to 15 degrees. Therefore, this one is equal to tan of A, where A is 45, and B, which is 15. And 45 minus 15 is 30, so tan 30 degrees is equal to 1 over root 3. This is under the particular angles. I think we covered that in O-level. So basically that's what they wanted. Now let's see how much can be awarded. So m1 is for expanding numerator and denominator. So this expansion, that is m1, then m1 for dividing through by cos A cos B, and this b1 is for the output, then b1 for both values of A and B, m1 for substitution, and b1 for the required proof. So that was question 1. Now we shall go to question 2. Question 2 came from UNEB 2009, paper 1, question 2, and says, given that equation, show that tan theta is equal to 1, and hence find theta if theta ranges from 0 to 360 degrees. So we are going to start by quoting the given equation. Then we remember that this one, sine A minus B, we shall go back to our identities and say that sine A minus B is sine A cos B minus cos A sine B. So we shall come here and write that our A is theta and our B is 45. A is theta, B is 45. Then for this side they want cos A plus B. So shall go and look for the identity for cos A plus B. So cos A plus B is cos A cos B minus sine A sine B. So shall come here and say that this is our A and this is our B, this is our A and this is our B. So I think realize why mathematical logbooks are very vital, because in those mathematical logbooks all these identities are there and what can be simplified. So next is to divide through by cos theta cos 45. Like we said, we want to express in terms of tan. That is why we have to divide by cos cos and not sin sin. So in this case, this one divide by this, you realize that cos cos cancels and sine over cos gives you tan theta, which is that. Then this one divide by this one, you realize that cos cos cancels and sine over cos gives you tan 45. Then this one divide by this, you realize that this and this cancels and this cancels, so you remain with only 3, which is there. Then lastly, this one divide by this one, you realize that sine cos gives you tan theta and also sine cos gives you tan 45. So after that I will make tan theta the subject. So remember tan 45 is positive 1, so that's why there is positive 1 here and positive 1 there. Then make tan theta the subject, take this one this side to come up with 4 tan theta, and take this one this side to come up with 4. When I divide both sides by 4, I come up with tan theta equal to 1, and that is what was required. This is what was required, but they also say that hence find theta. So hence means that you start from where you have stopped. So arc tan theta will give me 45 degrees, but tan theta is positive in the first and third quadrant. I think you remember that. So in the third quadrant, the angle will be 225 degrees. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for expanding the left hand side and M1 for expanding the right hand side, M1 for dividing throughout, M1 for the expression of tan theta, and A1 for both angles. So this would have been B1, not A1. So that was question 2. Now we shall go to question 3, which came from UNEB 1999, paper 1, question 3, and says, solve this equation for values of theta ranging from 0 to 360 degrees. So the first thing to do is to write down the equation. Then we remember that from the identity, cos A plus cos B is equal to cos A cos B minus sin A sin B. And also sine A plus B is equal to sine A cos B plus cos A sine B. So that is what we are going to use to expand that. So when we expand, we are going to come up with this is A, this is B, this is A, this is B. In this side, this is A, this is B, this is A, this is B. So n is okay. After that, we are going to divide through by cos theta. So when I divide through by cos theta, I'll come up with that, because this one cancels. Here, this sine over cos gives me tan, and here sine over cos gives me tan, and here cos over cos gives me 1. So next is to make tan theta the subject. So collect like terms, put tan theta on one side and the other one on the other side. Therefore, that means that tan theta will be equal to that. When I use the calculator to work out this, I'll come up with tan theta equal to 0.2679. Therefore, theta is equal to 15 degrees and 195 degrees. I believe you know how to use the quadrants to get this other angle. So basically, that's what they wanted. Now let's see how much can be awarded. So M1 for this expansion on the left hand side, this one for the right hand side, M1 for dividing through, M1 for expression of tan theta, and this one is for both angles correct. So that was question 3. Now we shall go to question 4, which came from UNEB 2008, paper 1, question 2, and it says, without using tables or calculator, show that tan 15 is equal to 2 minus root 3. So what we are going to do, we shall come and say that tan 15 this 15 can be got by saying 60 degrees minus 45 degrees. Therefore, we shall come and expand this using tan A minus B. If you look at these identities, tan A minus B is equal to tan A minus tan B over 1 plus tan A tan B. So in this case, it will be, this will be our A, and this will be our B, this will be our A, and this will be our B. Now 60 is a particular angle, and tan 60 is root 3. Then 45 is also a particular angle, and tan 45 is 1. So come and substitute. This is that, and here there is a plus, that's why you see a plus. Here there is minus, that's why you see minus here. Now because there is a side in the denominator, and in our proof they want the side to be only in the numerator, we have to rationalize. So when I rationalize, I'll come up with that. So open brackets for this, I'll come up with this. Open brackets for this, I'll come up with that. Then when I simplify further, this with this gives me 4, which is there, and this one is there. This with this gives me 2, which is there. Then from there, these two divide both. So 4 over 2 gives me 2, and 2 root 2 over 2 gives me 2 root 3 over 2 gives me root 3. And basically that's what they wanted. So let's see how much can be awarded. So M1 for this expansion, B1 for this output, M1 for rationalizing, B1 for this output, and B1 for the required proof. So that was question 4. Now we shall go to question 5, which came from UNEB 2016, paper 1, question 10b, and says, show that if this is that, then this is that, and hence solve this equation for values of x ranging from 0 to 360. So the first thing to do is to rewrite the given equation, which is that, and after that you shall remember that from factor formula, sine A plus B is sine A cos B plus cos A sine B, and sine A minus B is sine A cos B minus cos A sine b. So we shall come here and use that expansion to expand that. So when I expand, this will be act as our a and this acts as our b. Act as a, act as b. Here act as a, act as b, act as a, act as b. Okay, now next is to divide throughout by cos a, cos x, cos alpha. So cos x, cos alpha throughout. With this one, sine x over cos x will give me tan, and cos alpha over cos alpha gives me 1. Then for this one, cos x over cos x is 1. Then sine alpha over cos alpha is tan alpha. Then this one, sine x over cos x is tan x, and cos alpha over cos alpha is 1. Then this one, cos x over cos x is 1, and sine alpha over cos alpha is tan alpha. So next is to collect like terms of tan x and tan alpha. So put tan x on one side and tan alpha on the other side. Then you factorize out tan alpha and tan x, come up with that. Then next is to make tan x the subject. So tan x will be equal to that which is required. So basically that's what they wanted. Now let's see how much can be awarded before we got the hence part. So M1 for this expansion, M1 for this expansion, M1 for dividing through, and B1 for the required proof. Then in the hence part, they want you to solve this equation for values of theta x ranging from 0 to 360. Remember, they have used the word hence. So using the word hence means that you start from where you stopped. So in this equation, it implies that alpha is 20 degrees and p is 2. Therefore, from this proof where we stopped, that's where we shall start from and say that tan x is equal to 2 plus 1 over 2 minus 1 tan 20 degrees. Therefore, tan x is 1.0919, and therefore x is 47.52 degrees and 227.52 degrees. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for the substitution, A1 for the angles required. So now we shall go to double angle identities. So these identities are also in the mathematical logbook. So at first we saw this requiring Pythagoras theory, that is 12 to 13. Then we saw from 15 to 17, which require compound angle family. Now we are going to double angle, and this double angle we shall look at the ones from here up to here, that is 18, 19, 20, 21, and modified 22, which is why I'm using the word modified 22. So 18 says that sine 2a is equal to 2 cos a sine a, and 19 says that cos 2a is equal to cos squared a minus sine squared a, and is also equal to 1 minus 2 sine squared a, and is also equal to 2 cos squared a minus 1. Then 20 says sine 3a is equal to 3 sine a minus 4 sine cubed a. And 21 says that cos 3a is equal to 4 cos cubed a minus 3 cos a. Then note says that if t is equal to tan a, then sine 2a is equal to 2t over 1 plus t squared. Cos 2a is equal to 1 minus t squared over 1 plus t squared, and tan 2a is equal to 2t over 1 minus t squared. So the reason why I say that modified 22 is because if you look at this 22, here t there is tan a half a, but here we have tan a, and also here we have sine a, sine cos a, tan a, and here we have sine 2a, cos 2a, and tan 2a. So the identities, these ones are the same, because the concept is that what is here must be half of what is here. For example, if you look at this, this is 2a, meaning that this one must be half of this 2a, which is a. That's why I say that it is modified 22. So all these identities can be proved. All these identities can be proved. So in this part, we are going to prove all these identities to see how they come about. So you start with question 1, where you have to prove the identity. So we shall say that if t is equal to tan a, prove the following identities. One is that sine 2a is equal to that, then this is that, this is that, and this is that, and this is that. So let's start with part A. So part A, we wanted you to expand sine 2a. So what we are going to do, we should remember the identity of sine a plus b. So if you look at this one, it is sine a plus b is equal to sine a cos b plus cos a sine b. But in this case, what we have done, we have made b equal to a. That's why you see here sine a plus a. So it means that you are going to get sine a cos a plus cos a sine a. And when you do that, you realize that these are the same terms, so you are going to get 2 cos a sine a. So the order doesn't matter, you can say 2 sine a cos a or 2 cos a sine b. All is the same since it's a product. So that was part A. Now we shall go to part B. So part B, they want you to expand to show that sine 2a is equal to, maybe let's see the question. They want to show that sine 2a is equal to 2t over 1 plus t squared, where t is tan a. So they want you to express sine 2a in terms of tan a. So what we are going to do, we shall say that since we already know that sine 2a is 2 cos a sine a, we are going to come and put it here, and denominator will now be 1. But we know that from these trig identities, that 1 is special. We can come, this 1 is equal to cos squared a plus sine squared a. Therefore, we shall come and substitute here. Where there is 1, we shall put there sine squared a cos squared a, and this one will remain. Then from there, since they want it in terms of tan, we shall divide both sides by divide both numerator and denominator by cos squared a. So for the numerator, 1 cos a goes with this, and 1 cos a makes this one tan. But here there is 2. Then for the denominator, for this term, sine squared a over cos squared a gives you tan squared a. Then this term cos squared a over cos squared a gives you 1. But remember, t is equal to tan a, so where there is tan a, we are going to put there t, and also put here t. So basically that is what they wanted in part B. So before we go to the next slide, let's see marks for this slide. So M1 for expanding using compound angle formula, and this one is for the required proof. M1 for expanding 1, this from here to here. M1 for multiplying both numerator and denominator by that, and B1 for the required proof. So that was part B. Now we shall go to part C. I want to show this equal to this, equal to this, and equal to that. So we shall also use compound angle formula. We know that cos A plus B, if you look at this, cos A plus B is equal to cos A cos B minus sine A sine B. So the question is, if B is equal to A, what happens? It means we're going to get cos A, which is that. Therefore, that will be cos A, and also minus sine A, sine A. So this is a product of two identical terms, so it becomes cos A squared, and this one is a product also of sine A, which becomes sine squared A. So this was one of the proof which was required. Remember, there were three proofs in this cos A. One was that to prove that cos 2A is equal to cos squared A minus sine squared A. Now this identity is very confusing to students. I want you to distinguish it from the one in the mathematical tables. So in the mathematical tables, here it is plus, it is cos A squared plus sine A squared, that will be equal to 1. But if it is cos A squared plus sine A squared, it should be read as cos squared A plus sine squared A equal to 1. But if it is cos squared A minus sine squared A, it is no longer equal to 1, but it is equal to cos 2A. So always remember that is confusing to many students. That was the first part of the proof. Now for the second part of the proof, we shall use this very identity you have seen here, that cos squared A plus sine squared A is equal to 1. So when I make sine squared A the subject, it will become 1 minus cos squared A, and I substitute it here. Substitute for sine squared A, I'll come up with this, and when I open brackets, it will become that, and this is what was required. That was the second part of the proof. Now the third part of the proof, we shall instead make cos squared A the subject, and substitute it here to come up with that. Then open brackets, it will become that. So basically, those are the three parts of the proof which was required in part C. So M1 for this expansion, B1 for the required proof, M1 for this substitution, B1 for the required proof, M1 for this substitution, B1 for the required proof. So now part D, they want you to express cos 2A in terms of t, and part E, they want you to express tan 2A in terms of t. So let's see how those are good. So we start with part D. Cos 2A, we already saw in part C that cos 2A is equal to cos squared A minus sine squared A, and the denominator will be 1. So this one will be replaced with this identity of sine squared A plus cos squared A. Then from there, since they want it in terms of tan, we shall divide both sides, both numerator and denominator, by cos squared A. So for this one, this and this gives you 1, which is there, and this with this gives you tan squared A, which is there. Then this with this gives you tan squared A, which is there, and this with this gives you 1, which is there. But remember that t is equal to tan A, so this becomes t squared and this becomes t squared, and basically that is what they wanted. So now we shall go to part E. So tan A, we know that tan A is equal to sine 2A over cos 2A. But we already seen that sine 2A is equal to 2 cos A sine A, and cos 2A is equal to cos squared A minus sine squared A. So since they want it in terms of tan, we shall divide both the numerator and denominator by cos squared A. So for this part, one cos goes away and the other cos makes this one tan, and here this with this gives 1, which is there. Then this with this gives you tan squared theta, which is tan squared A, which is there. But we know that t is equal to tan A, so this becomes t and this becomes t squared, and that was the required proof. So let's see how much can be awarded. So M1 will be for this expansion of 1 especially, and M1 for this division or multiplying by 1 over that, then B1 for the output, M1 for this expansion, this for that division, and B1 for the output. So that was question 1. Now we shall go to question 2, which came from UNEB 2019, paper 1, question 2, and it says solve this for values of theta ranging from 0 to 360 degrees. So first we are going to write this equation which is there. Then next is to realize that this is 2 theta and this is theta. So this one we shall go back. Our aim is to get a quadratic, so we are going to go back in our identities and look for a quadratic which has a quadratic which can express cos 2 theta in terms of cos squared theta. So if you look at this, there is cos 2a, and here there is, the first one has cos and sine, that one you don't need it. This one has sine squared only, but we want in terms of cos, so this one we don't need it. So what we are going to use is this third one which has cos squared. So we are going to write 2 cos squared a minus 1. Now our a is theta, so we are going to write it like that. So this one becomes 2 cos squared theta minus 1. Then when I open brackets and I'll come up with that, then collect like terms to get a quadratic, then use bulldozer or factorizing to solve for cos theta. Therefore cos theta will be negative 0.75 or 2. So for this one, these are the values, 41.41 and 318.59. Then for this one it is undefined. I think we have already talked about that. It is beyond the maximum value of cos theta. Therefore the values of theta are these ones. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for expanding this to come up with that, and B1 for getting this quadratic equation, M1 for solving, B1 for the values of cos theta, and A1 for both angles. So that was question 2. Now we shall go to question 3, which came from UNEB 2016, paper 1, question 10a, and it says solve the equation, this equation, for values of x ranging from 0 to 180. So we're going to first rewrite the equation. Then from there we shall express all in terms of the reverse of the angle. Remember this one, if you look at this, let's first go back to the identity. If you look at this identity, this one, you realize that this is equal to that. Now because they are equal, for this and this I can make sine squared a the subject, and to be equal to a half of 1 minus cos 2a. Similarly, if I equate this with this and I make cos squared a the subject, it will be a half in brackets 1 plus cos 2a. So that is what I will use here. So when I use that, this one will be changed to this. Now a half, remember it is a half in brackets 1 plus cos 2x. Now that a half with this 4 gives me 2. Also here, this a half with this 2 gives me 1. Then 1 in brackets will be 1 minus cos 2a. So that's how we can use the identity for double angle to change to do it in the reverse way. Then next is to expand and collect like terms. So when I collect like terms, cos 2x will be equal to negative 0.5. Therefore 2x is this and this. I think, like I said, if you look at this limit, it is it should not exceed 180, but here we have exceeded 180 because this is not x but it is 2x. So to get the maximum limit, you have to get this and multiply by 2 to get 360. Now since this is less than 360, it implies that you are still in the required range. Now when I divide by 2, I'll come up with 60 degrees and 120 degrees. I think you realize that now it is in the required range. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for the reverse of double angle for cos squared x, and this one for sin squared x. Then this one is for simplifying to get cos 2x, and this one is for the values of cos 2 or the values of 2x, and this one for the required angles. So that was question 3. Now we shall go to question 4, which came from UNEB 2014 paper 1 question 15a, and says that solve this for values of theta ranging from 0 to 90 degrees. So we're going to first rewrite the equation, the given equation. Then from there we realize that here there is sine squared theta, here there is sine 2 theta, here there is cos squared theta. So what should we do? Here we shall now first divide throughout by cos squared theta. So when I divide throughout by cos squared theta, I'll come up with this side. This will give me tan squared theta, but there's a 4 here. Then here one cos will cancel with this one, but the other cos will give me tan theta, but there's 24 here and there is a minus there. Then here this will cancel and remain with 35, and there is a plus there. This will give me 0. So now I've got a quadratic in terms of tan theta, so I can use bulldozer and come up with the values of tan theta. So when tan theta is equal to 2.5, theta will be that, bearing in mind the interval. Then when tan theta is equal to 3.5, theta is that. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for dividing through by cos squared theta, B1 for the quadratic, M1 for solving, B1 for values of tan theta, A1 for both angles correct. So that was question 4. Now we shall go to question 5. So question 5 says, came from UNEB 2004 paper 1 question 3, and says solve this for theta ranging from 0 to 360 degrees. So we are going to first rewrite the given equation. Then from there, here we have to remember the identity for double angle of sine. So we shall come back here and say, when we look at number 18, there is sine 2a equal to 2 cos a sine a. So we shall come here and expand that. So this becomes 2 sine a cos a. The next is to factorize. So here at this step, that is where most students get it wrong. What most students do, they will just cancel this with this since it is equal to 0, but that is not okay. So here we don't divide throughout by cos theta, we have to only and only factorize. So when we factorize out cos theta, we shall come up with this. So either cos theta is 0 or 1 plus 2 sine theta is equal to 0. Now for cos theta equal to 0, it implies that theta is 90 degrees, and for this it implies that theta is 210 and 330 degrees. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for double angle identity, to move from here to here. Then this M1 for factorizing, B1 for values of cos theta and sin theta, A1 for this, and A1 for these two. So that was question 5. Now we shall go to question 6. Question 6 says that solve the equation this for values of theta ranging from 0 to 270. So we're going to first rewrite the given equation. Now here we have cos and cosec. We don't have an identity which relates cos and cosec. So what we are going to do, shall remember that cosec is the reciprocal of sine. So this becomes 1 over sine. Then when I multiply throughout by sine theta, I'll come up with this part. And therefore, this one alone is an identity of double angle, reverse of double angle, because we know, if you look at this, we know that sine 2a is equal to 2 cos a sine a. Therefore, in this case, we are given 2 sine a cos 2 sine theta cos theta, meaning it will be equal to sine 2 theta. Therefore, 2 theta will be equal to that, and theta will be equal to 45 and 225 degrees. So basically, that's what they wanted. Now let's see how much can be awarded. So M1 for expanding this, and M1 for reverse of double angle for sine 2 theta, and this B1 for this first value, B1 for the second value, and A1 for both values correct. So that was question 6. Now we shall go to question 7, which came from UNEB 2003, paper 1, question 9a. And it says that show that cot A plus tan 2a is equal to cot A sec 2a. So first of all, we shall begin from the left hand side. Here remember we are saying show. It means that we begin from one side, go to the next side. So from here, I remember that cot A is equal to cos over sine, and tan 2a is equal to sine 2a over cos 2a. Therefore, when I get the LCM will be sine a cos 2a, which is this. Now, this LCM divided by this cancels and remain with this. Now, this times this is what gives you this cos a cos 2a. Then also this LCM divided by this, it means that this one cancels, then this multiplied by this is what gives you sine a sine 2a. Then from there we realize that this is the reverse of compound angle theory. Remember, if we go back here, we have cos A cos B minus sine A sine B, and here we also have cos A cos 2A plus, okay, here it is plus sine A sine B, meaning that we are going to use the lower part, which is cos A cos B plus sine A sine B, and this lower part, this side, it is minus. Now because it is minus, it means that that's why here we have cos 2A minus A. We shall first maintain the denominator, then we know that 2A minus A is A. Now here, some student may ask, why don't you say A minus 2A? Whether you say 2A minus A or A minus 2A, it is still the same, because cos of a negative angle is equal to cos of a positive angle. So if you want, you can prove it. You get your calculator and try to press cos of 30 degrees, then also press cos of negative 30 degrees. You realize that both values will be positive. So that is why, so here whether you say A minus 2A or 2A minus A, it will still give you the same. So here I would have got, so if you use A minus 2A, here I would have got cos negative A. Then after that, you remember that cos negative A is equal to cos A. So it is all the same. Then from there, this and this gives you cot, and one reciprocal of cos is sec. So basically that's what they wanted. Now let's see how much can be awarded. So M1 is for this expansion, and this one is for combining into one quotient. This one is the factor formula. So this one is not supposed to be factor formula. It was supposed to be compound angle formula. So that is the compound angle formula. Then B1 is for the required proof. So that was question 7. Now we shall go to question 8. Now question 8 came from UNEB 2006, paper 1, question 1, and says, prove that this is equal to that. So we shall start from the left hand side. Left hand side, this will be this. So we are going to first expand this using the identities. So if you go back to the identities of tan, here it was tan A plus B, it was tan A plus tan B over 1 minus tan A tan B. So when you come here, our A is pi over 4 and our B is theta over 1 minus this and also that. That is when it is A this plus this. What if it was this minus this? We shall still go back to the identity and say that tan A minus B is equal to tan A minus tan B over 1 plus tan A tan B. So we shall come here and say that this one is our A, this is our B, this is our A, this is our B, like that. So after that, you should remember that as long as you see this pi, it implies that the angle is in radians. So this pi over 4 is radians, and in degrees it is 45, and we also know that tan 45, if you press the calculator and you press tan 45, you'll get 1. Therefore, we are going to substitute where there is tan pi over 4, we shall put there 1 here, and also here we shall put there 1. Similarly, here it will be 1, and also here it will be 1. Then from there we are going to get LCM. LCM is this product which is there. Then for the denominator, so this, the whole of this, divide by this, it implies that this cancels and remain with this. Now this times this is what gives you that. Similarly, the whole of this LCM, divide by this, it implies that this cancels, remain with this. Now this multiplied by this is what gives you this. Then from there I realize that this is a difference of 2 squares, so it can be some difference. Then denominator we can still first maintain to become to get that. Then when I simplify this difference of 2 squares, here this and this cancels, you remain with 2, here remain with 2, but when you come here you realize that this one cancels, but this minus negative this was 2 tan theta. So what we have got 2 tan theta, and also we have got 2 here. So denominator is difference of 2 squares, which will be that. Now from there you are going to be keen with compare it with this double angle. If you compare it with this double angle of tan, here it is 2t 1 minus t squared, and also here we have 2 tan 1 minus tan squared. So that means that's a double angle. So if this is theta, here it will be 2 theta, but there is another 2 here. That is why you still have to maintain it there, maintain this one here, and this one becomes tan 2 theta, and this is what was required. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for expanding both terms, M1 for substituting and combining into one quotient, M1 for difference of 2 squares, and B1 for simplifying, and B1 for the required proof. So that was question 8. Now we shall go to question 9, which came from UNEB 1994, paper 1, question 5a, and it says express this in terms of tan theta. So there is a square root, but what you're going to say, we are going to first ignore the square root and say that this one alone, which is inside this square root, what is it equal to? So we are going to first simplify this, then we put the square root at the end. So we know that this is t is equal to this. Therefore, when we go back to the t formula using this modified one, sign this one, sign. Now when this t is a half a, here it will be a, but when it is a, here it will be 2a. So in our case it is 2 theta, that's why here it is just tan theta. So that means that for sine it will be 2t over 1 plus t squared, and for cos it will be 1 minus t squared over 1 plus t squared. So when I substitute, I'll come up with that. So this is for sine, this is for cos, and this is for sine. Now next is to get the LCM for numerator and also denominator. So for this one, LCM is 1 plus t squared, which is that. Therefore, 1 plus t squared divided by this is 1, so we remain with this one alone. This is what is here. Also this, it cancels, we remain with this one alone, which is here. But remember to use brackets. But when we come to 1, so this divided by 1 is 1, then times this one gives you 1 plus t squared. Remember to use brackets. That was the numerator. Now the denominator, LCM is still 1 plus t squared. So 1 plus t squared divided by 1 times 2, you come up with this. You come up with 2 in brackets 1 plus t squared, and this one, this times this is what gives you that, because this one cancels with this LCM. Now next you realize that this is the same as this, and since it is division, they will cancel and you remain with this over this. So that's what you shall write here, but with an expanded form. When I open brackets, this negative 1 and this negative becomes positive, then here negative 1, then this negative and this positive becomes negative. For this one, it becomes 2a 2t squared minus 4t. The next is to collect like terms. You realize that this and this cancels. Now this and this is negative 2, which is there. Then here 2 is common, so it can come out to remain with t squared plus 2t minus 1. Then also numerator 2 is common, so it can also come out, and this can cancel to remain with, this can cancel, and also 1t minus 1 here can cancel with this numerator to come up with only t minus 1 in the denominator. Now that we have simplified, we shall go back and say that therefore this given expression will be equal to the square root of 1 over square root of tan theta minus 1. Remember, t is tan theta. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for this t formula, and M1 for combining both numerator and denominator, so this and that. Then another M1 was for simplifying to get this, and B1 for the required proof. So that was question 9. Now we shall go to question 10, which came from UNEB 1993, paper 1, question 9a, and so that show that this is equal to this. I think you remember I told you that these proofs can be, these identities can be proved. So in the first case, we only saw the proofs of, if I am to take, we saw the proof of this, we saw the proof of this, we saw the proof of these ones, these t formulas, but we didn't see the proofs of these ones. So they are the ones pending in this part of double angle. So the first, in this case, we are going to look at this proof of cos theta, then afterwards we shall also look at this proof of sine theta. So here they're saying that prove that cos 3 theta is equal to that, and hence solve the equation, this equation. So we shall start from the left hand side. Left hand side, 3 theta is the same as 2 theta plus theta. Then from there we use the compound angle formula. So compound angle, cos A plus B is equal to cos A cos B minus sin A sin B. So that is what we are going to write here and say that this is our A, this is our A, and this is our B, this is our A, and this is our B, like that. So next is to expand this. So cos 2 theta, we saw in our identities that double angle for cos is this, but in terms of cos it will be 2 cos squared A minus 1. So that is why you see here 2 cos squared theta minus 1. Then for sin theta, sin 2 theta, we saw that it is equal to 2 cos A sin A. So here it will be 2 sin theta cos theta. So after that we shall open brackets, and when open brackets we shall come up with that. So sin and sin gives you sin squared, and this one with this gives you cos cubed. 1 by this gives you that. So next is to also change this. Remember in the proof they don't want sin theta. So what we are going to do, you have to go back to your identities and ask yourself, how can I change sin squared theta in terms of cos squared theta? So what I will do, I come here and bring this one this side, meaning that sin squared A is equal to 1 minus cos squared A. That is why you see here that this one has changed to 1 minus cos squared theta. Now next is to open brackets. When I open brackets, this gives me 2 times 1 times this is 2 cos theta. Then also 2, but there's negative here, so negative 2 times negative cos squared theta times cos theta is positive 2 cos cubed theta. Then when I collect like terms, this and this gives me 4 cos cubed theta, then this and this gives me minus 3 cos theta, and that was the required proof. So basically that's what they wanted. Now let's see how much can be awarded before we go to the hence part. So M1 for expanding, then M1 for double angle identity for both this and this. So it's given that step. Then M1 for expanding sin squared theta and opening brackets. So it's given that step. B1 for the required proof. So now we shall go to the hence part. Hence means that you start from where you have stopped. So for the hence part, let x be equal to cos theta. Therefore, from this given equation, you realize that this becomes cos cubed theta and this becomes 3 cos theta. Therefore, we have already proved that this one is equal to that. So that's why you're substituting it there. Then when I make it the subject, it will be that. And when I use the calculator to get the values of 3 theta, I'll come up with all these values, plus or minus, because of the given range. So theta will be equal to plus or minus that, plus or minus that, plus or minus that. But we know that x is equal to cos theta. Remember, the question did not ask for theta, it asked for the value of x. So we have to go back and get the values of x. So when theta is that, we have to get the corresponding value of x, and to be 0.9497. And when x theta is that, we have to get the corresponding value of x, and it will be negative 0.7461. And when theta is that, we have to get the corresponding value of x, and that will be negative 0.2036. So those are the 3 roots of this equation. So basically that's what they wanted. Now let's see how marks can be awarded. So M1 for substituting for x, then B1 for the value of cos 3 theta, B1 for all values of 3 theta, B1 for all values of theta, and A1 for all values of x. So that was question 10. Now we shall go to question 11. Question 11 came from UNEB 1997, paper 1, question 11, and it says part A, prove that sine 3 theta is equal to this. Then part B, find all the solutions of this for theta between 0 and 360 degrees, and hence find the solutions of this equation. So like I said, all these identities have to be proved. Now the one which was pending was this one of sine this, and that is what we are going to prove. We have already proved this, we have proved this, we have proved this, and we have proved this in this part. So when we prove this, we shall be done with this part, and we go to the next part which has these other identities. So let's complete this. So we are going to say that 3 theta is equal to 2 theta plus theta. Then from there we go back to our compound angle formulae of sine A plus B. So sine A plus B, sine A plus B is equal to sine A cos A plus cos A sine B. So we shall come here and say that this is our A, this is our B, this is our A, this is our B. The next is to convert, to use now the double angle identity, because in the proof, if you look at this proof, the angles are only theta theta, but here we have 2 theta and 2 theta, so we have to convert it in terms of theta. And also you should remember that they only want sine and not cos. That means that when you go to this identity of cos 2 theta, this cos 2a, this identity is not needed because it has sine. This one is not needed because it has sine, and this one is what we shall use since it has only cos. For sine 2 theta, it is only one identity, so there is no option, we have to put it there. So we're going to put this, so we're going to put this and this. So that is why you see here now sine 2 theta is 2 sine theta cos theta, but there's also another cos theta here. That is why you see here cos squared theta. Then cos 2 theta is 1 minus 2 sine squared theta. So that means that, okay, yeah, since here they want it in terms of sine, the identity to use was supposed to be this one. It was supposed to be this one because it's the one with sine. Okay, so now next is to open brackets. So when I open brackets and I also change this one because this one is still in cos, but we don't want cos, so we have to go back and remember the very first identity, that cos squared theta will be equal to 1 minus sine squared theta, and that is what we are writing here. That is what we're writing here. Then for this one we open brackets to come up with this part. Now when I open brackets further, I'll come up with this step, and then I collect like terms to come up with that which is the required proof. So before we go the next to part B, let's see how marks can be awarded for part A. So M1 for this expansion, M1 for double angle identity for both this and this, so this and this. Then m1 for expanding cos squared theta, which is there, and opening brackets, so meaning it's given at this second last step, and b1 for the required proof. So that was part A. Now we shall go to part B, which says that find all the solutions of 2 sine 3 theta equal to 1 for theta between 0 and 360. Note this word all. Then hence find the solution. Now note this word hence. Hence is very vital, means that you start from where you have stopped. Find the solutions of that. So for that, it means that bring this to this side to come up with sine 3 theta equal to 0.5. Then press arc sine, you come up with all these angles. Now we have been used to getting only 2 angles, but what if it's more than 2? So how do you know why did I put all these values? For you to know, go back to the extreme. What is the range? The range says up to 360. Now this 360 works for only theta. But what if it is 3 theta? If it is 3 theta, it means that you have to multiply 3 by 360 and you come up with 1080. So 1080 must be your maximum angle. So the question is, how do you generate these others? Because by now you know how to generate 2 angles for each identity, but what if it is more than 2? What do you do? So what do you do? Let's first see how to generate the first 2. So for the first 2, sine is positive. Now because it is positive, it will lie in the first and second quadrant. So first and second quadrant. Now for the first quadrant angles, you know how to get it. Then the second quadrant will be 180 minus alphas, which is the... So here we shall say that for this one, this is your first quadrant angle, it is 30. Then the second value will be got by saying 180 minus 30, which is 150. Now from there, all these ones proceed by adding 360 to each. Now why do we add 360 to each? This is the reason why. So when you go back to your quadrants, we have this and this. So an angle cannot lie here. Now because it cannot lie there, it implies the first angle will be this from here up to here. Second angle will be from here up to here. Now what if I want more than 2 angles? What do? It means that from here I'm going to first make a complete revolution and then go back to there. Now that is the reason why we have to, now a complete revolution from here up to here is 360. So that is why we have to keep on adding 360 to the angles we have got. So similarly, for this, I also have to first make a complete revolution and then come back to this. So that explains why we keep on adding 360 degrees. So now that you have understood that, we shall go back to and generate the other angles. So for example, if now I've got this and this, now to get this one I'm going to add 360 to this. Then to get this one I'm going to add 360 to this. Then to get this one I'm going to add 360 to this. And to get this one I'm going to add 360 to this. Now the question is, why didn't we add 360 to this to come up with the other angle? If I add 360 to 750, let me see what I'm going to get. So 750 plus 360, you are going to get 1110. But remember, the maximum angle was supposed to be 3 times 360, which is 1080. So that means that 1110 is outside the given range. So that explains why we stop at 870. So after getting that, The next is simpler because we shall divide by 3 to get theta. So this by 3 gives that, this gives that, this gives that, this gives this gives that, and this gives that. So that was part A. That was part B. Now for the hence part. Hence part, they want you to solve this. Now when I compare, so you have to compare. So if I let x be sine that, you imply that this is that, and that gives you this. If I rearrange, I want to make it in this form. That is why I'm rearranging. So what I've done, that's why I brought this. I brought this one this side and this one the other side to come up with this. Then from there I'll change it to this. Then when I reach here, I'll remember my identity, the one which I've just proved. Remember we proved that sine 3 theta is equal to 3 sine theta minus 4 sine cubed theta. So now that I've got 3 sine theta minus 4 sine cubed theta, the whole of this can become sine 3 theta. So I'll come and say that gives me that. So this 2 is this, then this one is this sine 3 theta, and this one is there. So you realize that this one is the very expression which is there. Therefore I can use these angles to get my values of x. So I'll come here and say that these values are the very values of theta because we already solved it. So I'm going to just recall them. So the first value of x will be got by obtaining. So when I put this and I also put this, I'll get the same value. So it will give me the first root. Then also when I get this and also this, I'll come up with this. It will give me the same value, and that will be the second root. And lastly, when I get this with this, I'll get the same value, which will give me the third root. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for value of sine 3 theta, then B1 for value of 3 theta, values, all values, then this one all values of theta, M1 for substituting for x, and M1 for simplifying to get this, then A1 for the first value of x, A1 for the second value, A1 for the third value. So that has been the double angle. Now we shall go to half angles. So these are got from double angle identities, and they include the following. So when you look at the identities for double angle, you will realize one thing, that where this angle is twice this angle, meaning that what is here is half what is here. Now for half angle, what we do, here we put a and here we put a half a. That is the only difference. That is why when you see here, if you look at this sine, this is sine 2a equal to 2 sine a 2 cos a sine a, and here it is sine a equal to 2 cos a over 2 sine a over 2. And when you look at this identity for cos 2a, this identity, when you put here a, here it will be a half a, a half a, a half a, a half a, which is this second identity. Then when you look at this one, I think this one is direct 22, because here there is a half a, so it is okay, this is okay. So note that from this you can make cos squared a over to the subject. So when I make cos squared a over to the subject, it is a half in brackets 1 plus cos a. But when I make sine squared a over to the subject, I'll get a half 1 minus cos a. So you have to be keen with this. So these are got from this identity of number 19. So when it is cos, it is plus, when it is sine, it is minus. So we shall be using that also frequently. So now we shall go to question 1. So question 1 came from UNEB 2014, paper 1, question 15b, and it says solve this for theta ranging from 0 to 360. So we shall say that let t be equal to tan theta over 2. Now we are using tan theta over 2 because here the angle is theta. If this angle was 2 theta, here we would have used t equal to tan theta, which was under double angle, but now here we are under half angle, so this angle is theta. Here it has to be theta over 2. When it is theta over 2, shall remember the t formula. So the t formula, the one of course, when you go back to the identities, the one of course is 1 minus t squared over 1 plus t squared, and the one of sine is 2t over 1 plus t squared. So that is the substitutions. Then after that we have to get LCM and multiply through by the LCM. So LCM is this, so multiply through by LCM, you come up with this for this, and this for this, and this for that. The next is to collect like terms. So I'll come up with a quadratic and solve it using either factorization or bulldozer method. So when I use bulldozer, I'll come up with this, and therefore the values of t will be 0.2 and -1. Now for t equal to 0.2, it implies that tan theta over 2 is 0.2, therefore theta over 2 is equal to 11.31 degrees, therefore theta will be 22.62 degrees. Also for t equal to -1, it implies that tan theta over 2 is equal to -1, therefore theta over 2 is 135 degrees, there implying that theta is 270 degrees. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for the t formula, M1 for quadratic equation, M1 for solving it, B1 for these values of tan theta over 2, A1 for the first that angle, and A1 for this angle. So that was question 1. Now we shall go to question 2, which came from UNEB 2006, paper 1, question 12a. So it says that solve the equation, this equation for values of x in that interval. So we shall first write the given equation, then remember that t is equal to tan x over 2. Why? Because here it was x, so here it has to be x over 2. Then I substitute in the t formula. For cos is that, for sine is that. Then multiply through by LCM and collect like terms to get quadratic. Solve the quadratic equation and get the values of t. Then for t is equal to 1.7165, tan x over 2 is that, x over 2 is that, and x is that. Also for t equal to -0.1165, tan x over 2 is that, x over 2 is that, and x is that. So basically that's what they wanted, and now let's see how much can be awarded. So M1 for the t formula, M1 for the quadratic equation, M1 for solving, B1 for the values, and A1 for this angle, A1 for that angle. So that was question 2. Now we shall go to question 3, which came from UNEB 2005, paper 1, question 9b, and says use the substitution t equal to tan theta over 2 to solve the equation this for the values of theta ranging in that interval. So you first write the given equation, then we use substitute t formula for sine and cos, then multiply by the LCM, collect like terms to get quadratic equation, then solve the quadratic equation and get the values of t. Then for t equal to 0.3723, it implies that tan theta over 2 is that, and theta over 2 is that, and therefore theta is that. Also for t equal to -5.3723, tan theta over 2 is that, theta over 2 is that, and therefore theta is that. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for T formula, M1 for solving quadratic equation, and B1 for both values, A1 for this angle and A1 for this other angle. So that was question 3. Now we shall go to question 4, which came from UNEB 2000, paper 1, question 2, and says solve this. Therefore, we shall first let t equal to tan theta over 2. Therefore, when I substitute the t formula, I'll come up with this and that. Therefore, multiply throughout by the LCM and collect like terms to get quadratic equation, then solve the quadratic equation. You'll come up with t equal to root 3 over 2. That means that tan, because we saw that tan t is equal to tan theta over 2, therefore that is that, they're implying that theta over 2 is 30 degrees and theta is 60 degrees. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for t formula, M1 for quadratic equation, M1 for solving it, B1 for the value of tan theta over 2, A1 for the required angle. So that was question 4. Now we shall go to question 5, and it came from UNEB 1988, paper 1, question 6b, and says that use the substitution t equal to tan theta over 2 to prove that tan squared 22.5 degrees is equal to 3 minus 2 root 2. So here we shall say that t is equal to tan theta over 2 and it's also equal to tan 22.5. So what does that mean? It means that half theta is equal to 22.5, implying that theta is 45 degrees. We know that from t formula that identity for tan is 2t over 1 minus t squared. Therefore, since theta is 45, shows that tan 45 is equal to that. But when you use the calculator, tan 45 is 1, so that's why you put here 1. Then when I cross multiply, I'll get a quadratic equation, which is t squared plus 2t minus 1 equal to 0. Then I solve it using bulldozer to come up with the values of t being equal to this. So negative 2 plus or minus root 8 over 2. But root 8 is the same as 2 root 2. And this is common, 2, 2, 2. So it can reduce to come up with negative 1 plus or minus root 2. That means that t is equal to negative 1 minus root 2, or t is equal to negative 1 plus root 2. But we know that tan 22.5, remember tan 22.5 is t, cannot be negative. Therefore, this one is not impossible. Therefore, tan 22.5 is negative 1 plus root 2. So now that you have got tan 22.5, we can come and get tan square 22.5 by squaring. So when I square, I'll come up with this, and I'll expand to come up with that. Then I simplify to come up with the required proof. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for this value of theta, then T1, M1 for the T formula here, M1 for the quadratic equation, M1 for solving it, B1 for the conclusion, and M1 for squaring, B1 for the required proof. So now we shall go to factor formula. So these are identities which are used to convert expressions such as cos A plus or minus cos B and sin A plus or minus sin B into a product, hence factorizing the expression. So these are also found in the mathematical tables and these are numbers from 23 up to 26. So 23, 24, 25, 26 are all under factor formula. So the first one says that sine A plus sine B is equal to 2 sine A plus B over 2 and multiplied by cos A minus B over 2. That is for sine A plus sine B. Then for sine A minus sine B, it is 2 cos A plus B over 2 multiplied by sine A minus B over 2. I think realize that for minus here, it is cos with a bigger angle, and for addition here, it is sine with a bigger angle. Then for cos A plus cos B is 2 cos A plus B over 2 multiplied by cos A minus B over 2. Then sin cos A minus cos B is negative. Know this word, negative 2 sine A plus B over 2 multiplied by sine A minus B over 2. So when it is plus here for cos, it will become cos cos. And when it is minus here for cos, it will become sine sine, but with a negative 2 here. So these identities can only be derived but not proved. Therefore, we don't need to know how they come about. So next, we also need to know the expressions of the reverse of factor formula. Now, these ones are somehow related to factor formula, but the difference is that in factor formula, you are given the expressions in terms of sum and difference, then you express them in terms of product. But in the reverse of factor formula, you are given the expressions in terms of product and you're expressing them in terms of sum and difference. But there is some relationship. So, for example, if you look at this, the first one is cos A cos B is equal to a half, in brackets, cos A plus B plus cos A minus B. So when it is cos cos, here it has to be cos plus cos. One will be sum and the other one will be difference. Now the difference between this and factor formula is that in factor formula, the angle was sum divided by 2, difference divided by 2. I think you see all these ones is sum divided by 2, sum divided by 2, sum divided by 2. And then the difference also divided by 2, divided by 2. But for the reverse, it is only sum and difference. Now this 2 somehow comes from this one because here there was a 2. Now when I take this one this side, it will become a half. So that is where this one somehow comes from. Then for sine sine, here it will be negative a half cos minus cos. So negative a half, because even here in cos minus cos it was negative 2 here. Sine sine. So if it is just sine sine, this negative 2 has to go this side. Then for cos sine cos, it depends on which one is greater. So for example, if A is greater than B, it implies that in this case it is sine with a bigger angle. So it will be related to the also factor formula where sine has a bigger angle. For example, if you look at these two, here, when you look at these two angles here, it is also sine cos and also this one is cos sine. But when you look at the angle for sine here, the angle for sine here is bigger than the one for cos. And when the angle for sine is bigger than the one for cos, it implies that it came from sine plus sine. Now similarly, even in the reverse, it implies that when the angle on sine is bigger, it implies that it will be sine plus sine. And when the angle on sine is smaller, it implies that it will be sine minus sine. But don't forget these are halves. So still these ones can also be derived, but since we are not interested in the derivations, we shall ignore the derivations. And that is because they cannot be asked in an examination. Otherwise they can be derived. So with those identities of factor formula and the reverse of factor formula, we shall go through a number of examples so for you to grasp and master them. So shall begin with question 1, which came from UNEB 2020, that was last year, of paper 1, question 1, and says that solve the equation, this equation for x ranging from 0 to 180 degrees. So what we are going to do, we shall first rewrite the given equation, then we use factor formula. So factor formula of this and this, sine plus sine, we shall go back here and say that for sine plus sine, what is the identity? Sine plus sine is equal to 2 sine a plus b over 2 cos a minus b over 2. So we shall come here and say that if this is a and this is b, it implies that here it will be a plus b over 2. So this plus this is 4x. Now 4x divided by 2 is 2x. That's why you see here 2x. Then a minus b over 2. So this minus this is negative 2x. Divided by 2, it is negative x. So that's why you see here cos x. Now someone may ask, why don't we put cos negative x? So like I said under the trig identities previously, that cos of a negative angle is equal to the cos of a positive angle. So here whether you put negative x, it will still reduce to cos x. Now next is to realize that here there is sine 2x and also here sine 2x. So what we are going to do, we are going to factorize out sine 2x to come up with sine 2x in brackets 2 cos x plus 1. Then that means that sine 2x is equal to 0 or cos x is equal to negative 0.5. Therefore, for this one, 2x will be equal to 0 degrees, 180 and 360. Now this one is still outside this range because it is for 2x. 2x means that the maximum will be this by 2 multiplied by 2. Then for cos x equal to negative 0.5, x will be 120. Then for this side, when I divide throughout by 2, I come up with 0, 90 and 180. Then this side will be 120. Therefore shall list and there will be 0, 90, 120 and 80. So those are the angles they wanted. So M1 for factor formula to write this, then M1 for factorizing, B1 for the output, A1 for each part, so A1 for this part, and also another A1 for that part. So that was question 1. Now we shall go to question 2. So question 2 came from UNEB 2003, paper 1, question 3, and says, solve this for values of theta within that interval. So we're going to first rewrite the given equation, then we shall use factor formula. So factor formula, we shall pair this and this. Now the question is, why do we pair this and this and not this and this? The reason is because if I pair this and this, you realize that the sum will be this plus this, which is 5 divided by 2 to be 2.5 theta. But when I pair this with this, the sum will be 4 over 2, which will be 2 theta. And when you look at this, this is also 2 theta. So the ones you pair, you must make sure that after pairing, you get an angle which is similar to the one which has been left. So when we pair this and this, we shall get an angle which is similar to the one which has been left without using factor formula. So that is the reason why we pair this and this. So the choice of what to pair matters and is very, very vital. So when I use factor formula for this and this, it is cos plus cos. So I'll go back to the identities and look for cos plus cos. So when I look for cos plus cos, cos plus cos is 2 cos cos. Therefore I'll come here and say 2 cos, this one will be 2 cos cos. 2 cos sum divided by 2, which is this plus this over 2, and also cos difference divided by 2. So this minus this over 2 gives me theta. The next is to factorize out cos 2 theta, and then that means that cos 2 theta is equal to 0, or the whole of this is equal to 0. Therefore, for this one, it means that 2 theta is equal to 90 and 270, and for this one, it means that cos theta is equal to 120. Therefore, theta can be 45 degrees, 135 degrees, or 120 degrees. So basically, that's what they wanted. Now let's see how much can be awarded. So M1 for factor formula, M1 for factorizing, B1 for output, A1 for this first set of angles, and this one for the second set of angles. So that was question 2. Now we shall go to question 3. So question 3 came from UNEB 2016, paper 1, question 6, and says solve the equation. So this equation for values of theta. Now I think we realize that because there is pi over 4, it implies that our theta has been measured in radians. So we shall start by first quoting the given equation. Then from there we shall rearrange. So when I rearrange, I take this one this side, and when I take it that side, you realize that I can factorize, because this is cos for theta and this is also cos for theta. So when I factorize it out, I remain with this in the bracket. Therefore, for this in brackets, I can use factor formula. So cos minus cos, I will go back and look for the expansion of cos minus cos. Now cos minus cos is negative 2 sine sine. So I'll come here and write negative 2 sine of the sum, which is this, and this over 2, which is that, and also sine of the difference divided by 2. So difference this minus this over 2 to give me 2 theta. So next I'll take everything on one side, and then I'll realize that cos 2 theta is common. So cos 2 theta is common in this and also in this. Therefore I'll factorize it out. When I factorize it out, I'll come up with that. Now where is this 8 theta coming from? Now this one is coming from the reverse of double angle. So you realize that 2 sine 4 theta cos 4 theta will be equal to sine 8 theta, because 2 times 4 theta is 8 theta. So now this means that sine 2 theta is equal to 0, or sine 8 theta is equal to negative 1. So that means that 2 theta is 0 and 8 theta is 270. Therefore theta is 0 degrees, and also for this side theta is 33.75 degrees. But remember, the range was in radians, so we have to convert these ones to radians. Therefore we shall come and say that theta is equal to 0 rad and 33.75 pi over 180 rad. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for factorizing, another M1 for factor formula, then M1 for factorizing again, then B1 for both angles in degrees, so this and this, then A1 for both angles in radians. So now we shall go to question 4, which came from UNEB 2017, paper 1, question 12A, and says express this in the form r sine p sine q, where r is a constant, and hence solve this equation. So we shall first write the given expression and say that given expression in terms of factor formula, it is cos minus cos, so we shall go back and look for the expansion of cos minus cos. So cos minus cos is negative 2 sine sine. So here we shall come and write, now this will be our A and this will be our B, therefore negative 2 sine sine. Here we shall put the sum divided by 2, so this plus this over 2 is what we put here, as you can see it here. Then this side we put this minus this over 2, as you can see it there. The next is to simplify. So when I simplify, the whole of this angle will become theta plus 39 degrees, and the whole of this angle will become negative 9 degrees. So we know that sine of a negative angle is equal to negative sine that angle. So this negative will come out and cancel with this negative. That is why you see here a positive, and here the angle is now positive. So basically that's what they wanted, because it is now in the form of this r sine p sine q. Now we shall go to the hence part. Hence part, they want you to solve this equation. So come and first rewrite the equation and say that we have already seen that this one is the same as this. So what does that mean? It means that we shall come and replace. So replace it with that. When I replace that, this is a constant, so I can take it this side to come up with sine of theta plus 39 being equal to 0.6392. That means that theta plus 39 is equal to 39.74 and 140.26. When I make theta the subject, it will be 0.74 and 101.26. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for factor formula, B1 for this output, B1 for the required expression. Then M1 for this substitution, and B1 for the values of theta plus 39, and A1 for the values of the required angle. So now we shall go to question 5, which came from UNEB 2007, paper 1, question 12B, and so that solve this for the range of x, which is that. Now when you see this pi, it implies that the angle is in radians. So we shall come and first rewrite the given equation. Then we are going to rearrange. Now why do we rearrange? Like I told you, you rearrange so that the angle which comes out after factor formula is similar to one of the other angles. So for example, for this one, if I do this and this, it will be 5 over 2, which is a fraction. Also this and this will be 5 over 2, which is a fraction. So we shall now rearrange such that we get an even sum, so that when we divide by 2 we get a whole number, not a fraction. So when I do that, I'll bring this one this side and this one this side to come up with this line. So after that I can do factor formula. So factor formula, I think realize that now the angles are whole numbers, they are not fractions. Then from there you realize that this and that are common. But now the problem or the mistake most students make is that when they reach this step, what they do, they will say that this is 2 cancels, and also this cos x cancels with that. So once you cancel this trig identity or this trig ratio, it implies that you are going to ignore some of the angles which are required. So we don't cancel. What we do, we take all the functions on one side and we factorize. So we have to take this one this side, and then we factorize out cos x and factorize out 2 cos x to come up with that line. The next is to realize that this one factor formula can work. So when factor formula works for this, we'll come up with this. So that means that either cos x is 0 or cos 5x over 2 is 0 or sine x over 2 is 0. So before I go to the next slide, let's see how marks can be awarded for this slide. So M1 for factor formula on this side, another M1 for factor formula on this side. Then M1 for factorizing, and M1 for another factor formula here, and B1 for this output. So next is to get the corresponding values of x. So you come here and say that for x, cos x equal to 0, x is equal to plus or minus 90 degrees. And for sin x over 2 equal to 0, x over 2 is 0, implying that x is also 0 degrees. However, for cos 5x over 2 equal to 0, it implies that 5x over 2 is equal to all these values. So hope by now you know how to get multiple angles. So when I make x the subject, I'll come up with all these values. Now starting in the given range, because they wanted the range from negative 180 to 180 degrees first, then after that we convert to radians, which will be negative pi to pi. So when I use that range, I'll come up with these values. Now, how are those values got? So first of all, you have to remember the quadrants. The quadrant, we say that angles which are negative are measured from the positive horizontal axis going in the clockwise sense. So when I come here, 36 is okay because it is within the given required range. 108 is okay because it is within the required range. This one is also okay. But when we come to this 252, so 252 is going to be in the third quadrant. So in terms of negative angle, I will have to measure this remaining angle. So this remaining angle will be 360 minus 252. So when I say 360 minus 252, I'll come up with 108, but to be negative. So that explains why you are seeing here a negative 108 degrees. It is because of this 252. Then similarly for this 324, I also say 360. So 360 minus 324 to come up with 36, but it will be negative, so that is why you see here a negative 36 degrees. Then 180, it can be positive or negative, because 180 positive, it means you are measuring from here up to here, but you can also measure it from here up to here. So that is why you see here plus or minus 180 degrees. Now for the required range, we are going to list all the angles. So when you list all the angles, we shall come up with that. But remember, the angles, they wanted them in radians. So we are going to convert from degrees to radians to come up with that. So basically, that's what they wanted. Now let's see how much can be awarded. So B1 for both these angles, then B1 for all these angles correct, then A1 for all these ones correct, and in radians. So that now we shall go to question 6. Question 6 came from UNEB 2004 paper 1 question 10b, and says that show that this is equal to this, and hence or otherwise solve this for this range. So we are going to start from the left hand side, and we shall say that left hand side, this one is the same as 0 plus cos A, and this one is 1 plus sin A. Now that 0 and that 1 will be replaced by cos 90, so 0, cos 90 is 0, so we shall put it here, and sin 90 is 1, so we shall put it here. When we do that, we shall come up with this. So here there is cos 90 and here there is sin 90. Now at this step we are going to use factor formula. So factor formula of cos plus cos is 2 cos cos. So 2 cos sum over 2, then cos difference over 2. Then factor formula of sin plus sin is 2 sin cos. So sin sum over 2, cos difference over 2. Then next we shall split the numerator. When I split the numerator, for example, this and this cancels first of all. Then for this one, 90 over 2 is 45. Then a over 2 is this a over 2. The same applies for the denominator. Now cos over sine is cot. That is why you see here cot, and basically that's what they wanted. So M1 for substituting this and this 0. Another M1 for factor formula in the numerator, another M1 for factor formula in the denominator. Then B1 for the required expression. So now we shall go to the hence part. So for the hence part, we shall say that now this one is equal to a half. It implies that we have already proved that this is equal to cot a over 2 plus 45 degrees. But I know that cot is the reciprocal of tan, therefore tan will be equal to this reciprocal, which is now 2. That means that a over 2 plus 45 is equal to 63.43 and 243.43. Therefore, when I make a the subject, the angle will be this, based on the given interval. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for replacing, which is that, then B1 for both angles of this, and A1 for this. So this one's not supposed to be there. So now we shall go to question 7. Question 7 came from UNEB 2018, paper 1, question 12b, and says that solve the equation this for this interval. So the first thing is to rewrite the given equation. Then we shall rearrange so that after factor formula we don't get fractions. Then we can go to our factor formula, which will give us that. And therefore, like I said, we can't cancel. We can't say that this and this cancels. That means that we'll be missing some angles. So the only option is to factorize. So bring everything on one side, factorize out sine 3 theta. So before we go to the next slide, let's give marks for this. So this is M1 and this is also M1, and this one for factorizing. So out of factorizing, next we shall use factor formula to come up with that. Then we simplify to come up with that. So that means that sine 3x is 0, or this is 0, or this is 0. Now for sine 3x equal to 0, 3x is that, and therefore x will be that. For sine 3x over 2 equal to 0, that is that, and this will be that. Then for sine 3x, so for sine x over 2 equal to 0, x over 2 is that, and therefore x is that. Therefore, the values of x are these ones. So M1 for factor formula, B1 for this output, A1 for all these angles correct. Now we shall go to question 8, which came from UNEB 2007, paper 1, question 4, and it says, show that this is equal to that. So what we are going to do, we are going to first rearrange. So when I rearrange, I'll bring this one here, and I'll bring this one here. Then also here, I'll bring this one here, because if I don't rearrange, I'll get a fraction. For example, this 1 plus 2 theta gives me 3. When I divide by 2, it will remain a fraction. That is why I have to bring this one this side. That after factor formula, I would have a whole number. So factor formula, this one gives me 2 sine 2 theta cos theta, and this one remains 2 sine 2 theta. Then for the denominator, this one gives me 2 sine 2 theta cos theta, and this one remains 2 sine 2 theta. Then 2 sine 2 theta is common, so I'll factorize it out, remain with this and that. Then from there I will use now the half angle. So from half angle we realize that cos theta will become 1 minus 2 sine squared theta over 2, and cos theta will also become 2 cos squared theta over 2 minus 1. Now this and this cancels, and also this and this cancels. We remain with negative 2 sine squared theta over 2 and positive 2 cos squared theta over 2. So the 2 cancels, we remain with this negative here, and sine over cos is tan squared theta over 2. So M1 for factor formula for both numerator and denominator. So this factor formula, then M1 for factorizing both, M1 for half angle, B1 for the output of both, then B1 for the required expression. So now we shall go to question 9, which came from UNEB 2014 question 3, and says that given that this is that and this is that, prove that this is equal to that. So we shall start by expressing P and Q in terms of factor formula. So cos minus cos is negative 2 sine sine, and because this negative and this negative can cancel to remain with P equal to 2 sine A plus B sine A minus B. Then for Q, sine minus sine is 2 cos cos, 2 cos sine, meaning that cos is the one with a bigger angle. That is why on cos there is A plus B. Then when I divide the two, P over Q, I'll come up with this is P, which is here, then Q is here, which is this. You realize that this and this are the same, so they cancel. This 2 is also the same, so they cancel. You remain with sine A plus B over cos A plus B, and sine over cos gives you tan A plus B. Therefore, when I go to start with the left hand side of sec A plus B is the same as square root of sec squared A plus B. Now sec squared A plus B can be expanded to become 1 plus tan squared A plus B. So now I already know that tan A plus B is equal to P over Q, so I'll come and substitute for tan squared A plus B to come up with that. Then get LCM. After this LCM, you realize that this 1 over Q squared can come out to become 1 over Q, which is this. Then inside the square root there will remain Q squared plus P squared, which is that. And if you realize, this was the required expression. So basically that's what they wanted. So M1 for factor formula for both P and Q. So this and this, that is M1, then B1 for output, then M1 for expanding this to come up with that, then M1 for substituting for tan squared A plus B, then B1 for the required expression. So now shall go to question 10, which came from UNEB 2001, paper 1, question 13, and says part A, show that this is equal to that, and part B, find in radians, know this word in radians, the solution of the equation this, for this range. So we shall start with part A. So part A, we know that tan is the same as sine over cos. So this tan x plus y over 2 is the same as sine x plus y over 2 divided by cos x plus y over 2. And this one is the same as sine x minus y over 2 over cos x minus y over 2. Then next we shall get the LCM to come up with that. Then after that we shall realize that This one is the reverse of compound angle, because if you look at the compound angle, this x minus y over 2 is on cos here, and this side it is on sine. Then a plus x plus y over 2 is on sine here, and this side it is on cos. Therefore it is related if we compare with the one of sine a minus b. So sine a minus b, here realize that when a is on sine here, this side it is on cos, and when b is on cos here, this side it is on sine. And when this is a minus, even here it is a minus. So that is what we have used to come up with this angle. If this is A and this is B, it implies that we will get AB to be A minus B. Then for this side, what we have done, we have used the reverse of factor formula. So the reverse of factor formula, we are given a product, we have to change into sum or difference. Now this cos, when you look at these identities, cos originates from cos plus cos. Therefore, that is why you put a half in brackets, cos plus cos. Now cos sum plus cos difference. In this part, we don't divide by 2. The reverse of factor formula, we don't divide by 2. Now next is to simplify. This half can go up to become 2, which is there. Then here you will realize that this and this cancels. You remain with y plus y, which is 2y over 2 to come up with y. Then this side also, this one becomes x and this one becomes y. So basically that is what they wanted in part A. So M1 for expressing tan in terms of sine and cos, M1 for combining into one quotient, so numerator and denominator. Then here a reverse of compound angle formula, which is that, and this is the reverse of factor formula. Then B1 is for the required expression. So now we shall go to part B. Part B, we are given that, and therefore the first thing to do is to rearrange. Then we can use factor formula for this to come up with that. Then you realize that sine 2x is common, so I'll factorize out negative sine 2x to come up with this. Therefore this is equal to that, or this is equal to that. So that means that for this one, 2x is that, and therefore x is that. Then for this one, x is that. Therefore the required angles are those ones. But remember, they want your answers in radians, so you have to convert to radians. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for factor formula, M1 for factorizing, B1 for output, B1 for angles for first part, which is that. Then this one angles for the second part, then angles in radians. So now we shall go to our formula. So our formula involves using the expressions of r cos in brackets theta plus or minus alpha and r sine in brackets theta plus or minus alpha. And these expressions are used in two ways, in two cases. One, when solving trigonometric equations in this form, and also when you want to find the maximum and minimum values of trigonometric functions involving this format. Now from compound angle formulae, we know that r cos theta plus or minus alpha is equal to this. Remember, that is under compound angle formula, which is this. So cos this plus or minus b gives you this. So here there is a plus up, here there is a minus up, minus down, plus up. So that's what you should remember. Similarly, for sin theta, that will be the expansion. So trigonometric functions in the form a cos theta plus or minus b sin theta are compared with r cos in brackets theta plus or minus alpha, whereas those in the form this are compared with r sin theta plus or minus alpha. So what does that mean? It means that when you look at this first term of theta, so if it is cos, your comparison will be with cos there, and if it is sine, your comparison will be with sine there. So that means that this one will be compared with this, because here there is cos and here there must also be cos. Now there is minus, because when you are expanding, here there was plus, and after expansion the sign must be the same. If this is minus, here it will be plus for cos, but for sine, if this is plus, this will also be sine, and if this is minus, this will also be minus. So when you compare, now this equivalent sign helps you to compare terms. For example, if I look at this with this, you will realize that sin theta here is also here, meaning that this remaining part is a, and here the remaining part is r cos alpha, so those ones will be equal. Then for this part, this with this, cos theta, so here the remaining part is b, and here the remaining part is r sin alpha, which is that. So that's what they mean by the word comparison. Then when I divide the two equations, I'll be able to get the value of alpha, which will be arctan b over a. Then from the first identity of trigonometry, I'll come and substitute for sin alpha and cos alpha to come up with this and this, implying that r is equal to the square root of a squared plus b squared, where a is this and b is that. So these two, for this r and this alpha, are very vital in this topic. So now we shall go to question 1, which came from UNEB 2019, paper 1, question 11, and says, express this in the form r cos in brackets 2 theta minus alpha, where r is a constant and alpha is an acute angle, and hence solve this for this range. So we are going to follow the same procedure which we have already seen in the introduction part. So this is equivalent to this, then after that we shall expand this to come up with that. Then from there we shall compare. So by comparison, you realize that this and this cancels, you remain with this r cos alpha being equal to 7. Then here this and this cancel, so you remain with r sin alpha being equal to 6. Then from there we can now come and get our value of alpha and also the value of capital R. Now that I know alpha and r, I'll come and substitute for r here and for alpha there. So when I do that, this is what I'll get. So basically that's what they wanted. So M1 for R formula, B1 for both comparisons, M1 for this division, B1 for the value of alpha, M1 for this substitution, and B1 for the output, and B1 for also for the required expression. So now we shall go to the hence part. Hence part, we are given this equation, so we shall remember that the whole of this is equal to that. Therefore, when I make cos the subject, it will be that, and when I make the angle the subject, it will become that. When I make theta the subject, the values will be that. So basically, that's what they wanted. So M1 for this replacement, B1 for this first value, another B1 for the second value, A1 for this value, and another A1 for this other value. So now we shall go to question 2, which came from UNEB 2020, paper 1, question 13, and says express 8 sine theta minus 15 cos theta in the form r sine alpha minus r sine theta minus alpha, where r and alpha are constants. Hence find the maximum value of this and the smallest positive value of theta at which the maximum value occurs. So we're going to first express in terms of r sine theta minus alpha. So when I expand that, I'll come up with that. Then I'll compare to realize that r cos alpha is equal to 8 and r sine alpha is equal to 15. That means that when I divide the two, I'll come up with alpha equal to 61.93. And when I use Pythagoras, I'll come up with r being equal to 17. So when I substitute for r here and for alpha there, I'll come up with that expression which they wanted. So M1 for this, B1 for this, M1 for this, B1 for this, M1 for this, B1 for this, and another B1 for that. So now we need the maximum value and the angle at which it occurs. So maximum value of that is equal to 17 times 1. Now why? Because we already saw under the graphs of sine that sine and cos are are maximum when their expressions are, when their ratio is equal to positive 1. So the maximum value of sine is positive 1 and the maximum value of cos is also positive 1. That is why we are putting here positive 1 here to come up with 17. Then the angle at which it occurs when the whole of this is equal to 1, positive 1. Therefore theta minus 61.93 is 90 degrees, and therefore theta is 151.93 degrees. So M1 is for this substitution, A1 for the output, M1 for equating to 1, B1 for this, and A1 for the required angle. So now we shall go to question 3. Question 3 came from UNEB 2009, paper 1, question 11b, and says that express y, which is equal to that, in the form r cos x minus alpha, where r and alpha are, r is positive and alpha is acute, and let's find minimum and maximum values of this reciprocal. So still we have go through the same procedure for our formula. So first expand to come up with that. Therefore, by comparison, r cos alpha is 8, r sin alpha is 6. When I divide the two, I'll come up with alpha being equal to 36.87. And when I use Pythagoras theory, r will be equal to 10. So when I substitute for this r and for this alpha, I'll come up with that expression which is equal to 10 cos in brackets x minus 36.87. So before I go to the next slide, let's see how marks can be awarded for this slide. So M1 for this, B1 for this, M1 for this, B1 for this, M1 for this, B1 for that, and B1 for that. Therefore, for the hence part, the maximum value of this will, because this is a reciprocal, it implies that the maximum value y will be maximum when the denominator is minimum. So when the denominator is minimum, it implies that the minimum value is -1 for this cos. That's why we put here -1 to remain with 1/15. Then for the minimum value, it implies that the denominator is maximum. Therefore, we shall put +1 for this cos to come up with 1/25. So basically, that's what they wanted. Now let's see how marks can be awarded. So for you to realize that the denominator must be minimum for maximum value, and also maximum for minimum value is B1. Then M1 for the substitution and A1 for the output, M1 for the substitution, A1 for the output. So more of the examples for this topic of trigonometry and other topics of paper 1 can be found in the book which I've written, and it's Mastering A-Level Mathematics paper 1. But we have also written the book of paper 2 which is there, and physics 1 which is there, also physics 2 is also there, and also for all level we have books of physics. Submath, we also have a book. O level, we also have a book. Math Question Bank, which is arranged topical. Similarly, for A level, we have topical questions for UNEB. So these books will be of good help if you are a student. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on further topics in trigonometry. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on further topics in trigonometry has been uploaded. As well, thank you for watching, and also if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.